Alright, and we are live. What's up, Node.js developers? Welcome back to another tutorial. Today is a special day because today we're gonna build our own REST API for an e-commerce application using Node.js, Express, Drizzle ORM, Postgres, Genezio, and a lot of other cool stuff that will make this project really special. So, the learning goals for today's video is going to be, we're going to set up a new Node.js project with TypeScript. I'm going to walk you through with all the configuration, and I'm going to try to make it less confusing than it currently is with all the tools available out there. Then we're going to learn the fundamentals of Express and how to manage routing, how to use controllers, how to use middlewares in order to build a RESTful API for an e-commerce application with products and orders CRUD operations: create, read, update, delete. Express is one of the most popular frameworks for Node.js to build APIs, and it's used everywhere, and it's very stable. It's a very mature solution that is very good to have the knowledge of it under your belt. And today, that's what we're gonna do. Then we're gonna learn about user authentication and authorization. After that, we're gonna use Drizzle ORM with a Postgres database for our data. So real quick, with Postgres, this is a very powerful database, relational database that we're gonna use. And Drizzle ORM is a little tool that allows us to easier interact with our database and to also let us maybe in the future switch our database to something else. Drizzle is a real powerful tool that makes this much more enjoyable and easier to work with, and they provide migrations and stuff like that that will make this build really powerful and production ready. Then we're gonna learn about request validations and error handling. Here we're again gonna use some tricks on how to combine everything together to make it easier and with less work on our side. We're gonna use Zod validations with Drizzle and with Express to automatically validate if the data that users are sending to our API is correct, and if not, how to handle gracefully the errors. Finally, we're gonna deploy everything to production on Genezio, which will allow our application to be served in production and to be integrated in our mobile and dashboard, which is coming a bit later. So the tech stack that we're gonna use, we're gonna start with Node.js and Express. We're gonna build everything in TypeScript, and we're gonna make sure that everything is strictly typed. We're gonna use Drizzle ORM to integrate with Postgres, and we're gonna use Genezio to deploy our API and to also host our Postgres. If you don't know, Genezio is the fastest full-stack cloud. I found them when I was looking for alternatives to AWS Lambda that would be faster and that would also support deploying frameworks. And I was very happy to find out that Genezio is doing exactly that. And probably you are aware of AWS Lambda, which is the holy grail of serverless functions, but the problem with AWS Lambda is this cold start. The cold start is a common problem for all the serverless functions, where the first requests in a while, they will always have this cold start. Basically, the function will take longer to execute because the infrastructure takes time to start the function. So as we can see, all of them, the cold start for AWS, Vercel, Google Cloud Compute, they're about 300 milliseconds, even to 500. But with Genezio, we can get cold starts up to 50 milliseconds, which is really, really powerful. What I really like about Genezio is that it also integrates with frameworks. So if we see here, we can host our React, we can host Next.js, and we can also host an Express API. That's exactly what we're gonna do today. We're gonna first build our Express backend, and then we're gonna, in a couple of simple steps, we're gonna wrap it up in a serverless function, and we're gonna deploy it to Genezio on a serverless infrastructure so that we don't have to worry about managing servers with really good cold start performance. Also, we're gonna use their database. We're gonna host a database through the Genezio dashboard, a Postgres database that we're gonna use later. Genezio is the sponsor of today's video. They made it possible. Thank you very much, Genezio, for doing that. And in this video, we're gonna learn more about how to use it to deploy scalable backends to full stack applications to the cloud. All right, so before we get started, I just wanted to mention that this is going to be a mega tutorial. This is going to contain multiple parts, and not actually multiple parts, but multiple applications. Today, we are building and we are focused on building a backend. The only goal is to build a RESTful API, and today we're thinking as a backend developer. We're gonna work with Node.js, and we're gonna build this RESTful API. In the next video, we're gonna build a mobile application for our e-commerce product, and we're gonna use React Native and Expo, and we're gonna integrate with the backend that we're building today. In the third part, we're gonna build a dashboard with Next.js from where admins and sellers can manage their orders, can manage their products, can manage everything about what they are selling on the platform. So this is going to be like a very in-depth project, but I hope you're gonna be able to use it as a starter for any of your projects that you might build in the future. If you're ready, I'm also ready, and we can get started. Let's roll the intro. All right, so as prerequisites, all we need to do is to have Node.js, and I recommend using a tool like NVM to manage Node.js versions. You need a Genezio account that we're gonna use to host our database and to deploy our Express.js. And you need the guide that I prepare for you, but you can also find all of these links in the description of this video. The guide will contain more information, will contain step-by-step instructions. I'm gonna actually open it up here. You can get access to it through this form, and on your email, you're gonna receive the guide. Give me just 1 second. So yeah, I was sharing the prerequisites, Node.js, Genezio account, and the guide that you can get at assets.notjust.dev/ecom. After you fill in the details, you're gonna receive a link to the guide that you can follow, and I'm gonna add more information here, more code snippets, so that you can easier follow along step by step, take some stuff that we have here, and build this together with me, and maybe use it later when you need to use some of the stuff that you're gonna learn today in your own projects. So let me say hello to everyone who is joining us live. How are you doing, guys? I just lost a bit the chat. Here is the chat. Everything looks good so far. It took a bit of time to start the live stream because my Wi-Fi is giving me troubles today. And I was trying to like the Ethernet cables. I just have the cables, I have the connectors, and I have to connect them. I remember like 10 years ago, I was doing this kind of stuff like so easily, but now like I tried and I spent like 20 minutes trying to fit in the cables and to connect them, and I failed. And I said like, let's hope that the Wi-Fi today is gonna be on our side. How are you doing, guys? Hello, everyone. Will we cover JWT? Yes, we're gonna cover JWT for the authentication, exactly. Good to see everyone. Vladimir, Code Mercenary, Javier, Life is Games, Binay. How are you doing, guys? All right, so a lot of things that we have to do today. Where is the... Let me do it this way. I'm gonna share here. Like this. Let me set up some of my windows. And we can get started. So go ahead, open the guide that you received on the email, and let's start from the setting up a project from the e-commerce backend. So to set up our project, I'm going to start by opening a terminal. I'm going to navigate where I keep my projects, and I'm going to start by creating a new folder for my project. So let's call it full stack e-commerce. And let's go ahead and do a CD and go inside this full stack e-commerce. This folder is going to contain 3 projects: backend, the API, the mobile, and the dashboard. So let's go ahead and create a new directory here called API, and let's navigate inside this API. Now, if I do a PFD to see the path, we see that we are inside the full stack e-commerce folder and inside the API folder. Now that we are here in this folder, all we have to do is initialize an npm project. To do that, we're going to need npm and node.js. The node version that I'm using is the LTS version at the moment of recording this video. So that's 2018. In your case, that might be already 22, or if you're watching it later, it might be even later. But the tool that I recommend you use to manage this version is called NVM. And with NVM, you can do install LTS and then install the latest version. And after that, you can do NVM use LTS or also NVM alias default and the version, for example, 20 or 22, to set the default version of your Node.js to the latest. So npm for me is at version 10.9, Node is at version 2018, just for you to know what I'm using for this tutorial. Now that I have these tools, Node.js and npm, I can go ahead and write npm init and then -y to say yes for all the prompts. Or maybe let's not just do npm init. And this is going to follow the guide to set up the project. For the package name, instead of API, let's do ecommerce-API. And then for the rest, I'm going to do yes, 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 and then yes. Now, if I do ls here, we see that we have a new file called package.json. And that's everything that we need to have like a blank Node.js project. Let's go ahead and open. I'm going to do cd $DOS to go one directory up, and then code dot to open the directory of our whole project here in Visual Studio Code. From now on, I'm going to use mostly Visual Studio Code. Let me zoom in. And in this folder of our full stack e-commerce project, we have our API folder with our package.json. That's where we're going to have our API. Let's go ahead and open a terminal here. You can go at the top, new terminal. It's going to be open here. And when you open a new terminal, it's going to be in the root folder. Let's make sure to do cd API to go into our API directory. And make sure you're always in this directory when working with the API. Now what we need to do is we need to install Express. Express is a tool. It's a framework for Node.js to build web APIs. Here in the getting started, we can see in the installation guide how we can do it. All we need to do is npm install Express. So let's go ahead and do that. Npm install Express, enter. That will add the node modules with all the dependencies, and in the package.json we should have an Express dependency here. Because we are going to use TypeScript, I'm going to go ahead and install some development dependencies to support TypeScript. So let's do npm install -d for development, and I need TypeScript. I need tsx, which will help me execute on the fly TypeScript files with extension ts, and we're gonna use types express. These are going to provide us with types for the express. And finally, yeah, I think that's everything that we need for now. Let's install the dependencies, and this should add a new field in our package.json called dev dependencies, and these are dependencies only needed in development. After we build, we don't need them to ship them to production. So here we have them, the 3 dependencies that we added. Now let's go ahead and configure our TypeScript, and for that we're gonna create in our API directory a new file called tsconfig.json, and then tsconfig, we're gonna take it from the guide from here. I'm not gonna go in depth explaining all of the fields here, but these are the configuration for our TypeScript. And here, for example, it specifies where it will build. So the output directory is going to be dist. So when we build it, it's going to output it to the dist folder. Okay, now we can go ahead and set up our source directory. We're gonna keep the source files. Let's go ahead and create a new folder, src. And there, I'm gonna start with an index.ts. In the index.ts, let's go ahead and do a Hello World Express application. If I scroll down here, we can go to the Hello World, and this is the Hello World application. So we need to import Express, we need to create an application, we need to listen to that application and specify a GET request. I'm gonna write it manually because I would like to do normal module import, like import express from express. I'm going to create our application. So const application equal to creating it with express. I'm going to define a route like here, app.get. So app.get slash, what should happen when we send a request, a GET request to slash? We need to send hello world. And finally, we need to do app.listen port. And this port should be defined at the top. So let's do const port equal 3000. And when we call app.listen, we're gonna start our server and start listening and waiting for requests. Let's go ahead and try to run this function. And if we are going to try to run this index file using node source index.ts, we're going to see that, first of all, we cannot use import statement outside of a module. That means that we have to define that this project is of type module. Let's open package.json. And here, somewhere at the top, let's do type module. This will specify that we can use import format like this. And if I'm gonna try again to execute it, we're gonna see that unknown file extension TS. But what we can do is we can use an import field to say that, hey, import tsx, which is an executable for TypeScript files. And if I do that, our node could run this index.tsx because it was using this tsx runner. Now we see example app listening on port 3000. And if I go to a browser and do localhost 3000, what we see here is hello world. And that's our hello world API using Express. Hello, Francesco. How are you doing? Let's go ahead and I'm going to stop this server because I would like to go ahead in the package and add in the scripts, add a script. And scripts are basically commands that we can run again for our project, and these are things that we would like to pre-configure ahead of time. For example, I want to have a script called dev that will basically start the development server. We can start with running node -- import tsx and source index. And if I now run npm run dev, it's going to execute this command. What I'm going to also do is I'm going to also add here a -- watch field. And now if I'm going to run dev, Node.js is going to watch our files. So if I change something here, 1, 2, 3, and save, we see that it automatically restarts it. So these features are now built in Node, so we don't need other things like node-mon that you might be used to in the past. Now everything can be done with Node itself. And finally, for the configuration itself, what I like to do now is I will set here a .env file where we're going to store our environment variables. In the package.json, when we run our project, I'm going to say, hey, go ahead and use the env file called .env. And now if I do npm run dev, it's going to start, it's going to listen, and it's going to use the environment variables that later we're going to specify in this file, without us having to use .env package and so on. It's just as simple as specifying the file. So now we created this script with a lot of flags that we don't have to remember every time, because every time we need to run our development server, we're going to do npm run dev, and that's going to start running the server. Now, while we are here, maybe we can also cover the build command. Let's go ahead and add another script called build, and that script is going to simply run tsc, which is TypeScript compile command. And the TypeScript tsc command is going to look at the tsconfig, and based on this configuration, it's going to build our TypeScript project and convert it into normal JavaScript that can be run anywhere. It will look at things like output dir, which is dist, and things like that. So if I'm going to go ahead and stop the development server and do npm run build, it's going to execute tsc, and we now have a new folder called dist with the index.js. Now it's not index.js, it's index.js, and it will get rid of all the types that we will specify here. So in production, we can simply distribute this dist folder, but we're going to talk about that later. Now I just wanted to show you this command that we can set up for this build directory. Another thing that we're going to do in the next step, while also setting up our project, is going to be the Git repository. I highly recommend you to always use a Git repo to keep track of the changes in your project. And we're going to do that today as well. I'm going to go into the terminal, and we would like to initialize Git. I don't want to initialize Git for only the API directory. I want Git for the whole project that will contain three other projects: the API, mobile, and dashboard. So for that reason, either open a new terminal, or in here, make sure that if you do, for example, ls, you see the API directory, or if you do pfd, you know that you are in the folder of your project. Now being here, I'm going to go ahead and do git init. This will initialize an empty project, and if I will do git status, it's going to show me that if I commit now, or if I add files, the API is something that is not yet tracked, it's not yet added there. But I would need to know a bit more information about what exact files from API we will add. So what I'm going to do is I'm going to do git status API, or maybe cd API, and then git status. And here we see that we're gonna add the whole folder. I would really like to know the specific files that we're gonna add. So how do we do that? Because it just showed me the folder. Git status for a directory. That's something that I also need to know. Direct from within a directory. But I'm doing that and it doesn't show. The thing is that if we do git add and git push right now, we're gonna add two folders that we are not supposed, three things that we're not supposed to add there. First of all, we're gonna add node modules. Node modules is something that we should never add to Git because this is something that we can install based on the package.json. And they are quite heavy. So that means that in our API folder, I'll have to go ahead and create a new file called .gitignore. And in this file, we will specify files and folders that we want to prevent or to ignore in our repository. As I said, the first one is node modules. Another one is the dist, because the dist folder can always be generated by running npm run build based on the source directory. So it doesn't make a lot of sense to add it also to the repository. And finally is the .env file that will most probably contain secrets. You don't want to add it to Git. So I'm gonna add git env here as well. Now, yeah, I'm adding git ignore, but with git status, I need to know git. I will check it probably through the source control here. Doesn't really want to show me. I don't know. Let's try. I hope that I got rid of them correctly. And now I'm gonna do git add dot to add the current directory. Or better, I'm gonna move up into the root of our project and I'm gonna do git add everything from this directory. Now git status, yes. Now if we do git status after doing add, we see that we have a couple of new files. The git ignore, package lock, the index file and tsconfig. And we do not see the node module, the dist and the env file, which is good. Now I can go ahead and do git commit -m. Setup API and express. This is going to be our first commit. Now we can do changes, we can mess our project up, and at any point in time, if you commit often, if something goes wrong at any point in time, you can do a git status, make sure that you are only containing things that you can get rid of, and with very much cautious, you can do git stash so that it deletes everything and goes to the previous commit. I'm not sure why I showed you this because this is quite tricky, and use it with very much cautious and only when you know that things that you developed from the time you last committed, you do not need them, because this will delete everything that you have changed from the previous commit. And every time you add something, we're gonna do three things: git add dot, git commit and a message, and maybe git push after we connect it with GitHub, for example. Maybe if we're here, let's go ahead and I'm gonna show you how we can connect it with GitHub, because that's not super complicated. We go to github.com, we go create a new repository. I'm gonna choose the notjust.dev. I'm gonna give it a repository name. Let's go ahead and do full stack ecommerce. I'm gonna make it public and I'm gonna do create. Now I'm gonna grab from the second line, I'm gonna grab this command, git remote add, which will connect my local Git repository with the one I have on GitHub. So if I do this one and then do git push origin main, we take everything from locally, from the Git repository we have locally, and we push it here on GitHub, and we have the API folder, and we can also look at the commits that we have done. So that was our Git setup. Francesco is saying, great and ambitious project that you are embarking on for the next 3 videos. Awesome choice. Thank you very much, Francesco. I really wanted to do something like this for a very long time. And I'm happy to finally make it possible. Could you share your VS Code configuration, like the font you're using, theme, and any other custom settings? I don't think I have time today, but I'll try my best to create like a downloadable thing with everything in my configuration, and I'm gonna share with you guys in future. But yeah, like I don't think I have time right now because we have a lot of our goal for today is quite huge. Like we have a lot of things to do. So from the configuration, actually something that I'm going to show you is the following. Let me go ahead and do cd API and then npm run dev to start the development server. And we know that our server is listening to localhost 3000. We saw that initially we tested it with a browser by going and sending this request, by going to this URL. A browser, when you navigate there, by default is sending a GET request. But later we're gonna have other requests as well, like post, update, and so on. And while it's super easy to test a GET endpoint through the browser, it's not very convenient to test post and update endpoints through the browser. For that, the best option is to use a tool designed to help us test REST APIs. You could use Postman. That's something that I've been using a lot, but I think nowadays it become a bit overly complicated and it does too many things, but it's still a very good solution. But what I'm gonna use and what some of you guys actually showed me is an extension in VS Code called Thunder Client, right? That's how is it called? Thunder Client. Yes, it's this one. So if you search Thunder Client, go ahead and install it. And this is a client to test REST APIs. And we're gonna use it a lot today. So if I go now to Thunder Client here, what I can do is I can press new request. And in the right side, we have a URL. For example, we can do HTTP localhost 3000. And if I send the same request here, we have an error because it's not HTTPS, it's just HTTP. So if now I send, we see the hello world with status code 200. But we can do way more things, like we can do different methods that we're gonna send. We can do headers, we can do body, authentication, and so on. So today we're gonna use Thunder Client to test and send requests to our API. Good? Everyone on the same page? Hello, Horacio. How are you doing? I know we have to go to the Jiu-Jitsu. Actually, I was thinking maybe this week, but I was so busy preparing the live stream. But I would really love to go. Waiting for the file bundle to arrive. So the link did not arrive. It should. Double check the maybe spam and stuff like that. Let me close everything. Okay. So we are very good with the setup and the boring stuff. Now we are ready to get into actually building things. Before we start building our endpoints, I would like to go ahead and cover a little bit about the routes and how Express is doing that with routes, middleware, controllers. And I'm gonna try to do that slowly. As you saw, our application with Express, we can define this way, we can define our endpoints that our application will listen to. And we do that by writing application.get, for example, and we specify this is a GET request. This is the URL that we are listening to, and this is how we respond to it. For example, if we want to add a new URL endpoint for our products, I'm going to start working. To have a real example, I'm going to start working on our endpoints for our products. Usually we have around at least four endpoints for a specific model, and they stand for CRUD: create, read, update, and delete. So let's go ahead and start with an app.get for a GET request to the URL called /products. And this is going to, and the handler, the second parameter is the handler, is going to get the request, the response, and we can send back with response.send. Let's do the list of products. Now that we have our application being watched, it's going to restart. So I can go ahead and open a Thunder client request to play with. So if I go now and do /products and send, we see the list of products. So depending on the URL, we see hello world or list of products. So that's how we add two separate endpoints. When we're gonna want to create a product, that usually is a post request. A GET request is something that we are reading from the API, something that will never change the data there, such as like give me all the products, give me one product, and so on. When we want to create, usually we send a post request. So what we have to do is say app.post, because we want to define a post endpoint. Here we specify the URL. So the URL is also going to be /products. And in this case, let's add this endpoint and say new product created. So now we have the same endpoint /product, but different methods. One is get, one is post. If I'm going to go to our Thunder client, the get request here is still going to say this is the list of products. If I swap to post and send it, we see new product created. And if you have something wrong, it's going to say, hey, cannot post on this URL. So that means that now we have created two separate endpoints, one for getting the products, one for posting the products. And we're gonna add so on, like for example, app.update, app.delete for updating, deleting, or getting one specific product. But if we do everything in our index.ts, slowly it's going to get out of hand. Maybe let me show you one more. And then we're gonna move to the next step. Let's say we want to get a product with a specific ID. So that would be also similar to app.get /products, but we want a specific product. And the specific product, for that we're gonna use path parameters, and we're gonna put it in the URL here. So product / and here let's do ID with double dots in front. That's how we specify that this part of our URL is going to be the ID. And if I do now console log request and go to our API and do a get request to /product /123, we see I should return something else. A product. So the return is going to be one specific product. And in the URL, that has too many things, but if I do request headers and send again this request and look here, we're gonna see, where is it? No, how's it called? Request path parameters or parameters. Request.params. So it's called request.params. So if we look in the request.params and send this request again, we're gonna see that the parameters is an object and it has this ID with value 123. And that's how we're gonna be able to take the value from the URL that we are sending and use it to return the specific product. Okay, so now we see that we have a group of URLs. We have the group of URLs for products endpoints. The rule of thumb that you have to follow, I mean, you don't have to, but it's recommended, is to use the same prefix. So everything related to products is going to start with /products. Even the one that will return one single product is also at plural, /products/ID. That's because in the next step, we're gonna group them together and we're gonna use /product as a way to group them together. So how do we do that? I'm gonna also do it here and then we're gonna extract it into another function. So what we need is we need a router from Express. So Express also exports a router, which is a helper. So let's go ahead and here under products endpoints, let's do router equal router. Now, instead of doing app.get, let's do router.get, router.get, and router.post. I'm actually going to say that these are the product router, and a product router, we are going to attach it to our application. So after we finish our router things, we're gonna say, hey application, use this router. Let me double check if that's how you do that. App.use router. Now, let's go ahead and test if it's still working. 1, 2, 3 is still working. If I do /products, it's still working. If I do a post, it's still working. But we put everything into this router. Now, the nice thing is that we're going to take the thing that defines them together, the prefix /products, we're going to take it out of them from here, from the router itself, and we're going to say that the whole router is going to be under products URL. Now we do not repeat products because all of them are starting with products, and then this is the next part, the continuation. And if I'm going to send now request, it's working as it was working before, and the get as well. And what that allows us to do is to extract the logic, the routes related to our product to a separate file. So let's do just that. And in our source, let's create the routes folder. In the routes folder, I'm going to create our products. Let's actually create products as a folder as well, because I will show you later another benefit of doing that. So we have routes, we have products, and while we're here, I'm also going to create another folder called, let's say, orders, just to have them displayed properly in VS Code. And under products, let's create the index.ts for the product routes. I'm gonna take the router that we define in our index. I'm gonna take it from here until app.use, but app.use leave it here. We're gonna move a router in its own folder. We're gonna make sure to import router from Express, and at the end to export default router. Now, from our application, at the top, we no longer need the router, but we need the actual product router. So let's do product router, import from routes/products/index. And we're going to take this product router and we're going to attach it to the endpoint that starts with /products. And now let's see if the restart of the server happened correctly. It did. If I'm going to go to products here, no, if I'm going to send a request from here to products, it still works. And we know that it's coming from the specific file related to products. And we can say, hey, 1, 2, 3. If I go now and send this request, it's updated. We can do 4, for example, a product. So that's how we got here. That's why we need a router. It's nothing more than a way to group together multiple endpoints and split our logic into multiple parts. We're gonna have a product route, we're gonna have orders route, we're gonna have the authentication router with login, register, and so on. And in our application, we're just gonna simply put them together to their specific endpoint. So now we have it here. Perfect. I'm gonna go ahead in another terminal. I'm gonna do git add, git commit -m product router setup, or the boilerplate, because we just created the setup for it. And now what I will do is the following. Also a little bit around setup, configuration, files, folders, and so on. Another layer of abstraction, or another way to split up the code, is going to be to extract a controller from the router itself. So at the moment, oh, what happened here? At the moment, it might look that everything in the products router looks simple and that's the way to go. That's true, but later we're gonna add some middlewares, like a middleware to validate if a user is authenticated or not, a middleware to validate if the data is correct or not. And if we do everything here from validation to authentication and so on, and including the logic of handling a request, then the file is going to get a little bit out of hands. It's going to get too large. So the thing that we're going to extract from here is the logic of handling the request. So the router itself, the router file, will only specify, okay, this is a GET request to this URL, and I'm going to call a function. I will not implement the function, I will just call a function. So what I want to do is I want to extract these parts, these functions, in a separate file called controller. Or we can also be very specific, product controller.ts. So a products controller is going to have, for example, the first controller here. Let's call it export function list products, and I'm gonna paste this one. I'm gonna remove the arrow, and yeah, that should be it. We're gonna type it a bit later, but this is a function exported, that will handle what should happen with a request and response for listing the products. Now from our router, we're gonna simply import, how's it called? List products from products controller, and we're gonna call it when we're gonna attach it to the router basically. Now let's do the same for the rest. For example, we're gonna have, I'm gonna copy it multiple times. For example, this is, the second one is going to be get product by ID. I'm gonna console log the name basically to make it easier for me. The last one is going to be what? Create product. Create product. And then we have update product. So update product. And what other controller we need? We need the CRUD, create, read, update, delete. So delete product. And let's have them here. We see that we need to type the request and response. You'd think that we can simply do request from Node.js, but that's not true because Express itself has its own version of request and response with their own implementation of it. So we need to import request and response from Express and type the request and the response using them. Now I'm gonna copy this definition and put it for all of them. And after using cursor for a couple of days, like doing this manually for every row, like it's quite a challenge. But I'm trying to stick in these tutorials. I'm trying not to use like AI tools for autocomplete in order not to confuse you. I'd like to do everything together. And now that we have these controllers in our index, in our router, only thing that we need to do is import them, list, get, create, update, and delete, and simply connect them to the right endpoint. For example, this one, a get request to /ID is going to be get product by ID. Post request to / that's usually for creating a post. So let's do create product. Delete is quite simple because we do a delete, but when we delete, we need to know the ID as well. So we're gonna have this ID path parameter, and we're gonna connect it with delete product controller. And update is the same as delete, and I'm actually gonna put it before and only change here from delete to update, or not update, but put. So it's a put request. A put request usually is for updates, and the controller is going to be update product. And when we want to update a product, we also need to send there the ID of that product in the URL. So that's usually the 5 routes for one single model. We basically get a list of items. Then by sending the ID, we can get information about one single item. Maybe it will contain more data. We can send a post request to create an item. We send a put request to the /ID to update an item, and delete to delete an item. And now our router is quite simple, but later we're gonna add here validation and other middlewares. So the router responsibility is just to connect things. The controller responsibility is to specify what happens or how do we handle a request. Here is going to happen like the error handling, the creation, and so on. Now that we have this one here in the Thunder client, you can probably go ahead and save some of these requests in your activity. So you can create new requests. For example, one that we have here at the top, product /4. If we send, it's going to get product by ID. If I delete 4, it's going to be list products and so on. And you can save them. You can do new request and then press on this one and rename so that you can change here to get or list products, get products. And that is going to help you. Why I don't have a collection here, but should I create a new one? New collection. Let's do e-commerce. So in the e-commerce, when you have new request to HTTP, localhost, products. Let's, how do you save it from here? Is it from activity? Rename to list products, and then save to collection, and the collection is e-commerce. Submit. Okay, that's a bit too much, but now in under collections I have this list products that I can always come and send it. Now I can do the same. I can actually do a duplicate here, and let's do it /1. That is going to be rename get product by ID. Get product by ID. I'm going to duplicate it again and have a post, but in that case it doesn't need an ID, so it's /products for the post. If I send, it's going to be create product, so I can rename it to create product. Let's duplicate it again. We need it for update and delete, and we are good. So the update is a put request, but we need to send the ID there as well, such as /1 update product. Let's rename it to update product. And finally, we're gonna duplicate it for delete. Where is it? Duplicate. And we're gonna only change the method delete. If I send it, it's going to be delete product, and I will rename it to delete. Okay, so we have them set up here. I also encourage you to do the same, because it's going to help you test as we build. And we're gonna need it because we're gonna go back and forth and add more things. Like we're gonna add only the logic of creating, then we're gonna come back and add validations, then we're gonna add authentication and so on. So we're gonna move layer by layer through all of these things. Now we just learned about the fundamentals and how we can structure, how we can create and set them up. The next step is going to be logic, then validation, then authorization, authentication. So having them here is going to help you, because if you have done something on the create post, you just go here, you send it, and you double check that, maybe with the console logs that you're gonna see, or with exactly the answer that you're gonna get. So with that being said, we have the structure for our products, routes, and controllers. So I'm gonna do git add, git commit -m, products, router, and controllers. For all the CRUD operations, create, read, update, delete. Perfect. I'm gonna close everything so that we have a clean start. And we're gonna follow for the next, with the next things. Maybe it's time for commit. Thank you. Exactly. That was the time for commit. Git status. And if there is anyone watching this live and wants it access to the code live, I'm gonna do a git push origin main, and you can find it on GitHub already. So if we go to GitHub, it should be under notjust.dev. It should be somewhere here. View repositories, full stack e-commerce, and we already have 3 commits. I'm gonna also put this one in YouTube description, so you have access to it right now. Description, source code here. Oh, hello everyone. This is the second week that we are above 100 concurrent viewers. That's so nice. And because we have so many new people here, and because if I go now to YouTube Analytics, I can see that more than 99% of you guys watching this are not subscribed. This is from the analytics that YouTube is giving us. Let me introduce myself and maybe give you a reason why you should subscribe to the channel. My name is Vadim, and on this channel, my mission is to help you build impactful mobile application, learn about the new development tools to build and master, to build real world applications. I'm not really focused on teaching you like a lot of theory. I'm teaching you stuff like very practical skills that you can take and apply them to a real project and build something, launch an indie project, launch a startup, launch something on the side, because I think that's the true power of a developer. And we do have a lot of React Native Expo tutorials, but not only. For example, today we have a Node.js and Express tutorial. Sometimes we might do something on the infrastructure, sometimes on the backend, the front end, the web, everything that you need as a developer to build and launch powerful applications. So if you are interested, if I sold you with this, please make sure to subscribe to the channel. That helps us a lot to bring you more tutorials like this for you. And I'd appreciate it a lot. Thank you very much. Is it notjust or Express? It's Express. Okay, so what's our next step? Let's think how to slowly introduce the next steps. I think the next steps are going to be around already database and Drizzle. Because the next step is, as you can see, like in our routes, in our products controller, probably we're gonna start with creating a product. We need a way to create the product based on the information that we send here. Because the information that we're gonna send, it's going to be inside the request body. So if I go ahead here and do console.log request.body, we have already everything to get this information. We just need somewhere to store it. Because if now I'm gonna go ahead in my Thunder client for create product and send it here and look in the logs, we're gonna see undefined. But if I'm gonna go into the body and say that, hey, create a product with the name, let's say name iPhone and a price of, I don't know, $999. If I send them now and look into the logs, it's still undefined. Why? I don't know. Products body, and here products controller, console log request body. I know why. I know why. And that's good because we tested it, because we need a couple of helper functions or helper and middlewares that will go ahead and parse this body. Usually, like bare bone requests, they are encoded, so we do not have access to the body in a JSON format. However, Express, if I go into the source index, Express has a helper function called JSON that we can go ahead and assign it, or with app.use, pass it here. And now what it's going to do, is it like this? Should I call it? Yes, I need to call it. Now what it's going to do is, this is a middleware. So it's going to sit in between our application and our routes here. And whenever a request goes there, it's going to parse it to JSON so that we can have access to request.body in a parsed way, in a JSON format. So if I send the same request here, now we have request.body as a JSON. So I'm very happy that by mistake I got into this issue because I forgot to put JSON, but it showcases why do we need it. Because without it, the body is not a JSON format and we saw it as undefined. We need to parse it before. And with JSON, that is done on the application level for every request that will reach our application. And another middleware that is very helpful is the URL encoded. And I'm gonna add it here after we create the application.use, the URL encoded, and we're gonna do extended false. To be honest, I'm not 100% sure like why we need it. Only parses URL encoded bodies and only looks at requests where content type header matches with type option. Yeah, if you know, let me know. But these are the things that we need here on the application layer. And as I mentioned, with app.use, that's how we add middlewares. And I'm going to come back to middlewares a bit later when we implement some validation or authentications, because middlewares are a powerful concept in Express that allows us to add additional functionalities between controllers and as we handle the request. So as the request comes, it passes through multiple middlewares until we build it, we validate, we do everything with it, and we create a response. And the middlewares allow us to create these abstract functions or things that will look at the request and will do something such as validating or authenticating and so on. But I'm going to talk more about middlewares a bit later. I just wanted to specify that these two functions are a middleware, and with .use, that's how we assign them. And it's very important where we put them. Here we do app.use, and as you can see, like our router is also assigned with a use. So if we put it below, that's not gonna work because a request will go through the routes first, through the controller first, and only then it's going to go through JSON. And I believe it shouldn't work because it's undefined. The order matters. And the request will go through the middlewares in the order that we assign it to them. So first it's going to go through URL encoded, then JSON, then it's going to go through the product routes based on the URL, because if it's / it's going to go here. Perfect. All right. JSON parsing. Yes, thank you very much for the comment. Let me go ahead and do this small commit now. Git add, git commit, JSON parsing middleware, and git push origin main. Okay, so as I said, now we have basically everything. We have a request.body, we have controller, we have route, we can have access to that, to the data that we receive. The only step left is to go ahead and take this data and save it into a database. What we could do is we could connect, for the database that we're gonna create or use, we're gonna do a Postgres. So let's go ahead and first create it, and then we're gonna talk about the ORM stuff. So to host a Postgres database, you can do that locally on your machine as well, or you can use Genezio, that we're gonna do today, to deploy and host a database. Let's go ahead and create an account. You can do that for free. Let's go in our application, and under databases, with Genezio, we can easily create a Postgres database. For the name, let's call it ecom. It's going to be Postgres. You can also use a MongoDB, but for us, we are interested in Postgres. And for the region, I'm going to choose one that is closer to me, for example, Europe. In production, you'd rather use a region that is closer to your end user. Database with the same name already exists. Let's do ecommerce because I already have ecom. Let's create it. Here is my database. It's in EU Central. And if I press on connect, this is how we can connect to it. As you can see, from Node.js, we need PG, which stands for Postgres, and with PG, we can connect to the database. And then with PG, we can run queries, like create a table, run queries, and so on. That's good. We could do that. But in that case, we create a very tight connection between our backend and our database. And that might be okay if you're sure that you're always going to use Postgres. But that's not the only problem. Another problem is that running these queries manually doesn't feel quite right. I mean, you would have to know a little bit of SQL. You'd have to make sure that the queries are proper, we don't are properly defined, we don't have errors. Also, we have to manage a lot of things about the state of our database. For example, what happens if in a couple of months you decide to add a new field? For that, you need to change the structure of the database. You could do that manually, but then you might think like, okay, but what if I'm adding a field that is required, but there is no data? For that, we have to run migrations. So slowly and slowly, you're gonna understand that working with a database is not that straightforward. There are a lot of things to take care of. And a tool, or let's say a type of a tool that helps us interact with our databases is called ORM, or which stands for Object Relational Model, right? Is that what ORM stands for? Probably. There are a lot of ORM tools, but the one that we are going to use today is called Drizzle. So Drizzle is the ORM, it's for JavaScript, TypeScript, and it allows us to connect to databases like all of these: Postgres, Supabase, Vercel, PlanScale, Neon, and a lot more, SQLite. And it's also cool that it's made to be executed on the edge, like in serverless functions, such as this. And we're gonna actually use that today on the edge on Genezio. So let's go ahead, open the documentation and see the getting started. We're gonna choose a new database. We're gonna choose Postgres here. And this is the getting started guide for Postgres. Let's go ahead and follow it together and see how Drizzle will help us work with our database, manage it with migrations, and so on. I'm gonna go to the step 1 to install Postgres package. So let's go ahead and copy everything except the .env. We do not need .env because we already have access to the .env. That's what I'm trying to say. Let's install Drizzle ORM NPG, which stands for Postgres, in our application. I'm gonna go ahead, open the terminal. Let's probably stop the development server. Let's do a clear and make sure that you are in the API folder. Now we can go ahead and run npm I for install Drizzle ORM NPG. Hello Bugra, how are you doing? Did he answer the question on role-based access? Where is the question about role-based access? If you're asking if we're gonna allow some operations like for specific users like admins or sellers, yes, we're gonna add some authorization for role-based operations. For example, the products will only be able to be managed by users which have a role of seller, and end users will not be able to manage products. Okay, going on from the documentation, we see that we need a couple of development dependencies like Drizzle Kit and TSX and types PG. If I'm not mistaken, TSX we already have it, so it's optional, but let's copy it. And the Drizzle Kit is going to have a very nice tool that also we're going to see in a moment. It's the Studio. Now we need to set up the connection variables in our .env file, such as the database URL. So let's go ahead, copy database URL, go in our env file and paste here database URL. This is the URL of our Postgres database. We created the Postgres database with Genezio. So if we go back to our dashboard under databases, we have here ecommerce. I'm going to press connect, and the first one is the connection URL. Let's go ahead and copy it from here. Go back, paste it in our env, save, and close the env. This is a secret connection, so try not to share with publicly, because it gives access to the database, to your database. Now, back to Drizzle documentation. What we need to do is connect Drizzle ORM to the database. So let's go ahead and create an index file in our source database directory and initialize the connection. Let's go ahead in our source, create a new folder called db. And here, let's create the index.ts where we're gonna initialize the connection for Drizzle. So I'm gonna copy it from here. I'm gonna put it here, but I'm going to change it a little bit. And the thing that I want to change is I don't need to import .env because, as I said, we are managing environment variables in development using the env file. But in production, it's going to automatically be there. Like, we're gonna set the environment variables and they will be in the process.env. And actually, this way of creating the database, this is asynchronous, using await. If we scroll a bit to the next step, we see that there is another method to do it synchronously. So it's going to be easier for us to manage it because we are not going to have to await the database connection always. We're going to just get access to it. So actually, what I want is the second script for creating it synchronously. And to create it synchronously, what it does, it simply creates the connection pool for Postgres, and then with Drizzle, it just uses that pool. So let me do the following changes. I'll remove .env. I don't think we need all of this. I just need Drizzle from Drizzle ORM node Postgres and the pool from Postgres. I don't need the function main because I will not execute anything here. The goal of this file is to simply create the function and then export it from here so that other files can use it. Const db drizzle. Yeah, that's everything that this file needs to do. Creates the Postgres connection and gives it to Drizzle. Perfect. Now we need to create a table. For that, we're going to create a new file schema.tsx in our db folder. And I'm actually going to call it new file product schema.ts. That's where we're going to define a schema. And defining a schema is an abstract way of saying creating a table. With a schema, we set what fields do we need for the model, and Drizzle, or the ORM, will take that schema and will apply it, will create a table based on that. So as we can see, this is an example. I really like starting with examples. I'm going to copy it from here, paste in our product schema, and think, what do we need to change? First of all, it's definitely going to be the name of a table. It's not going to be users table. It's going to be products table. We create a product table with a PG table imported from Drizzle or RAM PG core. Here is where we specify the name of the table. That's actually the name of the table on the database layer. Usually it's lowercase and it's plural, so we are going to do products here. Then we specify the fields, and the fields have types that are also imported from PG core. In the documentation, if you go and search for Drizzle ORM types, maybe not custom types, but simply PostgreSQL column types, you're gonna see the different types that we can use, starting from integer to text, a boolean, double precision, which allows you to do floating point numbers, day, timestamp, and so on. So this is the documentation for all the fields, all the data types that we can use. Let's go ahead and start defining the schema for our products. So a product will have an ID. It's going to definitely have a name of type varchar. The length is going to be 255 maximum. Let's go ahead and also do, I'm gonna, after the name, add a description. Most probably an e-commerce application, a product needs a description. So the description is simply going to be a text. I'm not gonna do .not null because maybe a description can be null. The text will be imported here, and the text is a field of like variable sized text. It's probably also going to have a URL to an image. So let's do image of type varchar. But as well, let's not do it not null because it's going to be optional. It's not going to have an age. It's not going to have an email. But it's going to have a price. And the price is going to be, a price usually is a number, which can also support floating point numbers like dot something. So I'm going to use a double precision, which is an 8-bit floating number. So let's import here double precision, and the price is going to be double precision number. I think it's not null because the price is important for a product. Without a price, we cannot have a product. For that reason, I'm gonna maybe I'm gonna leave it here. Yeah, I think that's it. So these are the fields. Now I also want to pay attention to the ID. The ID is of type integer, and we also specify that this should be a primary key. In SQL databases, every table needs a primary key. That's how we identify one row in that table, and that's also how we're going to create connections between items from our tables. Because with using a primary key, we can enforce a lot of things, and the database engine is also optimizing requests. For example, when we're looking for a product by ID, it's going to be optimized when we search this because we are using a primary key. And here we say generated always as identity. We are specifying that the ID we cannot send the ID. It's always going to be auto-generated. Okay, so that's our products table. Let me go back to the documentation of getting started and follow a couple of more steps to set up our Drizzle. What we need is we need a Drizzle config file. This configuration file is used by the kit and contains all the information about your database connection, migration folder, and schema. So all we have in the source is used by our application, like by our API. The thing that we are going to add in Drizzle config is going to be used when we manage the database, when we manage migrations, the schema files, and so on. So let's go ahead and create it in the root of your project. So outside the source, inside our API folder, we're going to create drizzle.ts here. configuration for Drizzle. Let's import this object from the documentation. And again, I'm going to remove a .env. We import define config from the Drizzle kit. The output is going to go into the Drizzle. Let me just double check that with my configuration here. The schema is taken from source db schema, but we have product schema here. That's interesting. How can we use multiple schemas? Let me just I'm going to create here a file called schema.ts, which is the goal of this file is going to be to combine multiple schemas into one. So let me now for a second do import everything as products schema from the, this is something that I'm not 100% sure, but I think that's how it's going to happen. We're going to import the product schema and we're going to do export product schema, export default, and we export it like this. What do you think? We're gonna try this way. And when we add more products like users, orders, we're gonna have to come here and put them together into one combined schema. Now, if I go to Drizzle config, the schema is going to be taken from source database schema.ts. The dialect is Postgres. The database credential is taken from database URL environment variable. That's good. And there is a couple of more things like verbose that we can say to true, and it's going to show us more logs so that we know what's happening, and a strict true, which will enforce some more rules to make sure that we know like what's happening, like not to do some mistakes. Now we're gonna test it out, and in the step 6 we're gonna apply the changes to the database. What we can do is do npx push command. This is a method for quickly testing stuff. What it's going to do is going to look at our schema and it's going to push these changes to the database. It's going to skip this migration step that we're going to learn in a second, but for development that's pretty okay. So let's do npx drizzle kit push. npx drizzle kit push. So here we see pulling schema, no changes detected, and what happened? I don't know. Then we're gonna look about here, but give me 1 second. I want to start the studio. How do I start the studio? How do I start the studio? Oh, it's npx drizzle kit studio. So by running npx drizzle kit studio, we're going to run locally the studio for drizzle kit. Here is going to be the URL. Let's open it up in browser. And this is a very nice tool that I really love that allows us to interact and see our database. And we see that we do not have any databases yet. That's because most probably I messed up here the schema file. Schema file. Let me go into drizzle config schema. Who can help me here? Let me just search drizzle multiple schema files. Multiple config files. No, multiple. Oh, it can be an array, right? So that means that in the Drizzle config, I can put here products schema, and later I will put it in an array and add more schemas here. Will that work? Let's double check. Let's test it. I'm gonna leave the Drizzle Studio running here, and in another folder, I'm gonna do cd API, and let's do npx Drizzle Kit push to apply the changes. Okay, now we see you're about to execute the current statement. Create table products with these fields, and it will ask me if I want to do it or not. Let's scroll down to yes and press enter. And now we see changes applied. And if we go to Drizzle Kit Studio now, here, and do a reload, we should see that our database has a new table called products with these fields, with these columns. Perfect. So that means that everything is connected, and based on a Drizzle schema here, we created and we set up our Postgres database. Before we continue, I also want to go back into the getting started guide, because what we did now was we ran the push command. As we see here, this is a convenient method for quickly testing new schema designs in a local development environment. It allows for rapid iteration without the need to manage migration files. But later, when you go to production, you're gonna have to manage these changes through migrations. So with Drizzle Kit Generate, what we do is we look at the changes and we create a migration file. We create a file containing the SQL commands that we need to apply to our database to move it from the previous state to a new state that we have in our schemas. So these are the two commands that we need: generate, and then to apply the migrations, we do npx Drizzle Kit migrate. So let's go ahead and do that, but I'm gonna go into our package.json to add some scripts because I'm already tired of remembering what I have to do. So I'm gonna have a script db generate that is going to execute Drizzle Kit generate. I'm gonna have db migrate, which is going to do Drizzle Kit migrate, and I'm gonna do db studio that is going to run Drizzle Kit studio. So now if I go into the terminal here, do a clear, and if I run now npm run db generate to generate a migration file, we're gonna see a new folder appear in our API directory called Drizzle. Drizzle has this meta folder, snapshots, and some SQL files. For example, this one is the migration that, when applied, it will create the products table. Now I can go ahead and run npm run db migrate to apply this change, and it will take these configuration changes and apply to our database. At this moment, I'm going to go ahead and do a git add git commit -m Drizzle setup, and I'm going to show you what happens when later we decide to add a new field, or when we decide to change the schema or the structure of our database. For example, we go to source, to the database product schema, and we say that we need a new field in the products table, such as I don't know, quantity. Let's say quantity of type integer, and let's see default equal to 0. So we add a new field here, but on our database layer, if we look in the studio, we do not have a quantity yet. So the steps that we have to take to apply the changes is going to be, first, we need to create a migration. So we're gonna run npm run db generate to generate the migration. We see that one table is affected. If we look into the drizzle, usually you don't have to look there, but to double check that that happens, we have a new migration file. If we look at the file, what it's doing is it's applying the changes. So what SQL command should it run to apply the changes that we just did? So it will alter the products table and add the column quantity. Now, the only thing left to do is do npm run db migrate to take this migration and apply it to our database. Now, if I go back to the studio and reload, we see the quantity here. And the same thing will happen if you, for example, delete the quantity. You're gonna do db generate to generate by migration and db migrate to apply it and remove a quantity from here, and it's gone. And now we have 3 migrations. So whenever you initialize a project in another environment, it's going to go ahead through all the migration from the first one, and it's going to apply them one by one. First, it's going to create the products, then it's going to add the quantity, then it's going to remove a quantity. So that as a project grows, you're going to have a lot of these migrations, but you never have to manage them. Like, you create them once using Drizzle, and you just keep them there as a history or as an instructions on how to set up the database in the state that you need it. For now, I'm going to do a git stash because I committed before running these tests, so that I will remove these 2 files, these 2 migrations. And you can actually provide the name here, like create products or update, create orders, because if you don't, it's going to generate these random names. And if I do git status now, untracked files, but I removed them. Drizzle meta. Oh, Drizzle meta, these 2, right? Hopefully, by removing them, I'm not gonna break anything in my case. Let's see. If I do now git status, all good. If I do npm run db generate, will it say that it's no schema changes, nothing to migrate? That's what I was expecting. Clear. Perfect. So we have our database ready. It's time for us to interact with it, to save data, to query data, fetch, and so on. Sounds good? Are you still here with me? What's the timing? We are 1.5 hours. Good. I think we are on track, because we still have to implement the logic of the CRUD logic for products to create, read, update, delete in the database, then orders with order items, then authentication, then validation. So there is still a lot of things to do, but we are on a good track. What do you think? Let me know. Is it understandable? Am I moving too fast? Do you have any questions? What about API security? We're gonna implement authentication authorization for the API and make sure that only the allowed users are allowed to perform the actions that we need. About rate limiting for engines. Ajay is saying I'm doing side by side with a live stream with RDS. Perfect. That's also possible. It's just a matter of where we're connecting it to. And Ajay, are you following up nicely? Is it manageable? I'm gonna do a git push origin main. So for everyone who is following this live, you can look at the code if you are not managing. Will you create the front end for this project? Yes, exactly. This is going to be like a mega project. In today's video, we are focused only on the backend. So the focus of today is backend. We are building a REST API in Node.js. Then next part is going to be around mobile application. This is the user side application that will help us see products, create orders, and so on. We're going to do that with React Native and Expo. And finally, the third part is going to be a dashboard, a web application in Next.js for admins or for actually sellers to allow them to manage their products, to manage their orders. So that is the plan. Give me 1 second, I'm going to bring some water and we continue. You can also take a very small break, take some water, stay hydrated, and I'm going to be back in 20 seconds. Let me show you a new developer. Hello, Denchik. Say hi to everyone. I didn't even notice that he was here sleeping near my desk. Denchik, what do you say? Do you like our stack for today? Oh, let's go. Okay, Denchik has to go. Oh, we are ready. Oh, I forgot my water. Here it is. John is saying, great job, good pace, and love your clear explanation. Thank you very much. I appreciate that. And now we have to put them together. For example, when we send a post request to /products and call this create product controller, create product, we need to take the data from the request body and save it in the database. Let's go ahead and do that. I'll just open the documentation for some references, because there are two ways of interacting with Drizzle, an SQL-like and a non-SQL-like. And where is that information? Is it SQL-like? I think it was that one, query data. So under query data, there is this YSQL-like, and this is basically very similar to how you would run queries in SQL. And this type of queries is very powerful for people who have experience with SQL, because it has the same kind of keywords like database.select, from, post table, left join, where, and so on. And this will create the following select query. For people that do not have experience with SQL and want like a different querying solution, there is this query API that has a different syntax. For example, DB query, we are querying the users table, and we are trying to find many, and this is a way to also easier create relationships. So we're gonna use a mix of both. Whenever we need relationships, we're probably gonna use the query API. In the rest of the times, we're gonna simply use the SQL-like way of interacting with our database. So let's go ahead, and here is the insert command, and we need access to the database, insert, and these are the values. Let's go ahead and do exactly that here in the create product. The create product, first of all, is going to be an async function, because right now we're going to interact with async should be before function. So here we need access to await database that should be imported from source database. He doesn't know about index, so maybe we should do /index. Okay. I don't know why it's complaining. Oh, I need like relative path. So let's do db. No, it should be db, then index. Okay, so this is the database imported from our DB index, where we created it with Drizzle. Now, in the create product, we're gonna call db.insert. Here we need the table, and the table is going to be imported from product schema, products table. So let's go ahead and import. Why not configure the import alias? Maybe we could do that, yeah, but I'm a bit afraid. Because later on we're gonna, the TypeScript configuration, like, I'm afraid to touch it during a live stream. Like it can go wrong. Let's go ahead and import the products table from DB product schema. Now let's take the products table and specify that we want to insert in this table. And the values that we want to insert are going to be the request.body, basically the data that we receive from the user. If we do that now, and if we run our API doing npm run dev to run the development server, we have this issue. The requested module PG does not provide an exported pool. Yes, that's true. How did I solve it? Yeah, that's also probably something about my configuration, but the solution is going to be to go into the DB index, and instead of destructuring the pool, we're gonna import the default export there, like PG, and here we're gonna do pg.pool. Now, if I start the server, now it works. I can go to Founder client and I can do create product. If I send this request, everything worked fine. We don't get the answer back here. But if we look into the database, if we didn't have any errors and if I will reload, we should have something. Yes, indeed, we have a new item with ID 1 called iPhone 999. Perfect. That's exactly what we wanted to do. Now let's go ahead and add some of the things around this request, because we also would like to send it back to the user. For that, we need to say that, hey, database, give us back the newly imported item. And to do that, we're going to say returning at the end. This will not only insert it, but also will return us the newly inserted item, so we can get access to it here as products, because the returning always returns us an array. What you can do is you can destructure the first value from that array and call it product. So returning gives us an array where if everything worked fine, it's going to have only one item. So we are destructuring it from that array with a name product. Now, let's go ahead and instead of sending there a text, let's send there a JSON, and we're gonna send the newly created product. And usually you also send back a status code of 201, which stands for, I'm not sure if it's gonna tell us, but it stands for created. So now I can go ahead and send this same request again, and back I expect to receive a newly created product. So if I do that, processing, and I have ID 2. If I do again, there's gonna be ID 3, and so on. So that's, now we are receiving back the object of a newly created product. Perfect. Now I'm gonna probably remove this console log, and I'll put some error handling, because maybe if, for example, the user does not send the price and we send it here, we're gonna have a problem. Connection was closed. That basically crashed our whole server. What we need to do is we need to put this db insert, this operation, into a try catch. So we're gonna try to insert a product, but if there was an error, let's do a response.status 500 saying that there was some issue, and we can actually send the error back. Now, if I'm going to send the same request again, we're gonna see more details. Here I send the whole error, which sometimes you might not want to do. Maybe you want to just send a message like failed to create a product, because in some cases by sending a whole error, it might give more information to the user of the API than needed. For me, that's okay. And I see in the detail is that the row something column price does not match the constraint. So I know that I need to provide here a price. And if I provide here a string, it's also, it's going to work because it's going to parse in that with the help of Drizzle, but it should be a number. Okay, so now we have a create controller, and it's more or less ready because it has also error handling. It's trying to insert a product, and the only thing that we're gonna do later is going to be to add here some validations to make sure that the request body is exactly what we want it to be. So if I go ahead and reload, we already have some items here. Let's go ahead and continue our controllers, and I'm gonna start from the list. Here, usually I will start with a try catch. So let's do try catch error, and here let's do respond.status 500, and let's do JSON error. Was it JSON or just send? Let's do send. And I'm gonna take this structure and put it in every function that we need to implement now, so that I save a little bit of time not to write it try catch again and again, because we need this try catch in all of the functions. We can also make it at the global level to catch all the errors, but why I don't want to do that, because usually the errors here, you'd like to handle them here, maybe provide a detailed error message like why it happened, how to prevent it, and so on. So that's why I did it here. So let's start from the list products and see how we can list the products. Again, we're gonna use the database, the Drizzle database, or the Drizzle ORM to interact with our products table. So let's go ahead and say that here we're gonna look for the products using our DB, but in this case the operation is going to be select. We need to make this function async as well. So we are going to select dot from the products table. And in this case, we don't need the dot returning because a select is an operation that returns something. Returning is for other operations like insert, update, and so on. But here we are returning it. And here is going to give us an array, but when we list products, actually we need an array. So let's go ahead and do rest.json products, just like that. Now if I'm gonna go to our Thunder client and send a list products request, if I send this list products, we have an array of all the items from our database with their fields. Perfect, that wasn't too complicated. Now, get product by ID. Let me start with the same request that we did previously. I'm gonna do it here as well in the get product by ID. I'm gonna make the function async. And the only thing that I need to change here is I don't want to select all of them. I want to also add some filtering. And the filtering is going to be added with where clause. In SQL, we do where. And we are going to use the equal operation imported from Drizzle ORM, where we specify a column and a value. The column is going to be taken from the table that we are working with. So products table dot ID, and the value is going to be the value that we are looking for. For example, 1, let's say. Now, in this case, we don't need an array. We need only 1. So I'm going to destructure here from this array, and I'm going to call it with singular product. Now, there is also one thing. There might be cases where we didn't find the product. So if product is undefined, we're gonna send a status code 404. And maybe product not found. Otherwise, let's send rest.json. We're going to send the product there. So let's go ahead and test it. If I'm going to go to our Thunder client to get product by ID, if I send to product ID 1, it's going to give me the product ID 1. The problem is if I change it to 2, it's still going to give me 1 because what I did here is I hard-coded the ID that I'm using to filter by. The ID, we're going to take it from request.parameters. Remember, we are sending it through the URL, so we can get it from request.params. So I'm going to destructure ID from there because in the router, that's how we called it here. With double dots, that's the name, how we're gonna be able to access it. So here we're accessing it by the name ID, and I'm gonna use it here as ID. But the ID will be of type string, where the column name ID is of type number. So I can simply transform it to a number like this. Okay, now if I go back to get product by ID with number 2, this is the ID 2, 3, this is ID 3, and if I do 323, that's going to say status code 404, very important, and the message product not found. So this status code 404, you probably heard of it, you probably know about it, but if this is the first time you're building an API, HTTP statuses are very important. So go ahead and open the the sheet for knowing about more, to learn more about HTTP response statuses. We have like 5 categories starting from 1 all the way to 5. So everything that starts with 1 is going to be an informational one. 200, between 200 and 300 were status code that starts with 2. That means that something went successfully. 3 means a redirected request. 4 means client error. That means that the client that sent the request made an error. Maybe they didn't send the right data. Maybe they didn't format it correctly. Maybe they do not have access to it. So it's a client error. And 500 errors, this is bad. This is a server error, which means that something happened on the server that we couldn't handle it properly. So this is the fundamentals of HTTP statuses, and all of them, like they can be more in depth. For example, in the 200s, there is 200, which means okay, that usually for a get or a put. For 201, that usually means the request succeeded and a new resource was created. So that's why in our controller, when we created a product, we send the status code 201. It's not the end of the world if you send 200 here or if you don't send the status at all. It's still gonna work, but to comply with some standards and to make sure that it's on the front end is going to be easier to use to understand what happened with a request based on status codes, it's advisable to properly use them whenever possible. So that means that get product by ID is done with 404. Like if the product was not found, that means that this is not a server error. That means that you provided me an error, an ID, that there is no item for it. So try another ID. But if something bad happened here and we go into the catch, there's going to be a 500 error, a server error that we didn't catch, we didn't properly handle. Okay, so get product by ID is done. Let's go ahead to the next one. Here we have probably the delete is going to be easier, right? Let's try the delete one. So I'm gonna start with making it async. Let's go ahead and do await database dot delete from or delete. We need here to provide the table. Let me double check. Yeah, we delete from products table, but whenever calling delete function in SQL, that's also true. If you don't provide a condition, that means delete everything from the table. So it's very risky to do it like this. Always just have it in your mind, like when you call it SQL delete function, you need a condition. You need a where condition to specify what fields or what rows to delete. So here we're gonna do delete also by ID, where the products table.id is equal to the same request.params. So let's use here number request, or maybe a better way would be to right away transform it to a number here, I think. Number like this, and now the ID is a number, so I can use it here without having to worry about it. So a delete operation can also return the deleted item. That's only if you need that. You can do that with returning, and it will give you the item that was deleted. I'm not sure if we need that. I'm not 100% sure what's the best practice here if you need to return the currently deleted item. I think the only thing that is important, maybe to know like if an item was found with that ID or not, maybe. So a returning, and by taking here deleted product, you can check if it was found. That means that we deleted. If not, that means that it's a 404, like we didn't find the item that you wanted to delete. Maybe that's good for the backend to give as a response. So if deleted product, then we can return response.send. I think there is a 203, if I'm not mistaken. Deleted product should be. And a 203, that means 202 accepted. 204 is no content. So everything went okay, but there is no content to send for this request. So let's do 204, which means I'm not going to give you back the currently deleted item, which I can if I want, but I'm just going to say like there is no content, but 2 or status code starting with 2 means that it worked correctly. And else we can do response.send 404 with not send but status and send. I think we need both of them. And here status 404 send message product was not found. Let's go ahead and test this endpoint with our Thunder client under delete. We're gonna try to delete product with ID 1. If I send it once, we see 204 no content, which we can assume that, okay, the item was deleted. But if I send it again, we're gonna see, hey, there is already no item with this ID because you already deleted it. So maybe in the front end, we can use this information to say something went wrong, so I need to change something. And if I provide another ID that is not there, that, yeah, it's not even a number, like 112, product was not found. So probably that's a good thing to send. And now if I look into that database, we're gonna see that the item with ID 1 was deleted completely. Perfect. So the delete is done. What's left here for us is the update. The update will also have an ID in the request parameters because we're gonna know what item we're trying to update. But it will also have updated fields that will come from request.body. Now what we have to do is we're gonna make it an async function and we're gonna say, hey, database.update the products table, set the values to updated fields, and also we need a where condition to only update some rows, because if we don't provide it, it's going to update all the rows. That's also important. It's not update one, it's update all rows that match this where condition. So let's match the condition based on products table ID that matches the ID from the parameters. The update will also have this returning that we can use to get access to the currently updated field. So we can destructure it from that array, make sure to await it, and we're gonna take the product here. And we can do the same as we have done here with if else. The only thing is that if product, then return, I don't need the status, is 200 by default is gonna be good. So let's return a response a JSON with an updated product. Otherwise, a 404 because the product was not found. Now, if I'm gonna go ahead to test it, Thunder client, update product. If I do product with ID 1, I need to provide a body here. For example, name should be updated. It's going to fail because there is no product with ID 1. But let's try it. We see product was not found. If I'll try to update the product with ID 2 with the name updated, the name was updated, but all the other fields remain the same, like a price and so on. But I can use it to update, for example, the description. Description and maybe image or stuff like that. Here I will say iPhone 16 send. Something happened. Yeah, the field description. Oh, I had like an extra comma at the end, which was making the problem, but even like my name description is not correct. So it's description. Send. Now the name is updated, the description is updated, the price remains the same as it was in the past. So we are not overriding, we are updating the fields that we provide here. And with that, our products controller is complete. We started with listing by doing a database select operation, get product by ID by doing also select, but using a where clause to match based on an ID. We created a post using the insert and the values from the request body. We updated the product based on the ID and we updated them in the database. We deleted the product here, and that means that we are finished with this, with the whole CRUD operations for our products. So I can do git add, git commit -m product CRUD, and the whole CRUD operations are complete. Perfect. Okay. And now I can do git push origin main so that you can also have access to them. All right, so how are you guys? Still here? All right, I see that you are still here. That's amazing. What are you currently doing? Let me know. Are you at work and have this stream on the side? Are you at home trying to learn something? Are you in the middle of building a project? Let me know in the comments. Like, I'm really curious, like, how are you consuming the tutorials that we do here? Okie dokie. What is going to be our next step? If we look where, let's look here. We have Postgres, Drizzle, the schema, the migrations. We have a product CRUD. Next step is going to be data validation. And I usually introduce a new topic by showing the problem. And the problem is data validation. For example, a user in the Founder client will try to create a product and will say that, hey, first of all, he's not going to provide a price. We're going to send, and we see bad request, but it's not properly handled. Let's do it like this. Send 500. 500 means an error that was not handled. An error that, as developers, we didn't think about. This can happen, but it's usually better if it's an error that we handle gracefully or provide more details why it happened. Because in this case, it's not a 500 error, it's not a server error, it's actually a client error, meaning that the client did not send us the data that we expect. So with proper validation, we can look at this data, at this body, and say, is it following the same structure as we need in order to create a product based on this table? Well, it's actually not following because it doesn't have a price. So it's going to say, give us an error, a better error saying that the price is required. Or in case the price was a Boolean, for example, price true. I don't know, like I'm just throwing you some ideas. If that happened again, it didn't work, 500 error. The error is very bad, like a developer on the front end is not going to understand what's happening here. So again, we will look at the price. We need to make sure that the price is actually a number, and only then it's going to happen. So here is where we do data validation. We need request validation to make sure that the data that the user is sending is the data that we expect. In a way, we need to set some rules, some boundaries as an API to say what do we expect, make sure to give us that data. In the past, I'm not sure if I need to show you this, but in the past, that was like the library that you would use would be Express Validator. Express Validator. This is a library it's a middleware for Express that allows us to set some validation for requests. We can look at the documentation. We're not going to use it, by the way. I'm just showing you the library. We can look at their homepage. So let's do getting started. For example, in a endpoint handler, for example, get hello, before we handle the request and response, before that, we put here a middleware and we say query person not empty, which means that the query should have a person and it shouldn't be empty. So you see that all of these validation rules, we specify manually like this, validation rules, and then we take validation results, and based on validation results, we check if there are errors in the validation results, we're gonna handle them there. So it's a bit, it requires some boilerplate. Every handler, every controller in our case is going to at least have this part of taking if the results of a validation is not empty, then send the error. Another problem is that we're gonna have to create these validation rules manually ourselves, meaning that we're gonna have to look at our database in database product schema and rebuild these fields in the Express validator format, saying that, hey, I see that in our database name is not null, meaning it's required. So I need to go and specify that name should not be empty. So as you can see, it adds double work. We need to specify Drizzle schema, and on the other hand, we need to provide and create these validators. So I was not happy with this solution, and I was looking for a different solution. I know there is a nice tool for specifically TypeScript for validation called Zod. I was thinking, can we use Zod for these Express validators? And in fact, we can, and it's not that complicated. I looked at Express Zod validation. There are some middlewares, some packages that do it for us. But I found this blog, I think. I'm just showing you how I got to this solution, but we're gonna do it together. But I think I found this blog that did not use any package. It simply created a middleware called validate data that received a Zod schema, and it was parsing the schema. It was checking if there is any Zod errors by parsing that schema. If yes, it was sending request status bad request and invalid data with the error message, with the details from the error message. Then it was taking this validate schema and it was putting it on the router like this. That's cool. Just by defining this middleware like a simple function, we can use Zod schemas to validate. Zod is good, but that means that we need to create Zod schemas. Again, duplicating code because we have our Drizzle that specify the tables and we have Zod schemas. I was doing more research and I found out that we have Drizzle Zod, and Drizzle Zod is a way to create Zod schemas based on Drizzle tables. A lot of words, a lot of tools put together, but it makes it really beautiful in the end because a lot of things are automated and we don't have to write it twice, like schema, validation, tables, and so on. So we're gonna use that, and as you can see, for example, we create the user table, and then using this Drizzle Zod, we can create a Zod schema that specifies the fields for inserting a user or for selecting a user. So let's put these two together. Let me just think what's going to be the step-by-step to do it easier. So I have everything committed. What I'm going to do is, let's go ahead and first handle the middlewares and not think about Zod, or maybe think about Zod a bit later, but first let's talk about middlewares. As I said, middlewares are functions that sit between our server receiving the request and our server sending the response. So what happens is the data goes through middleware to middleware to middleware to middleware to middleware until it gets to the controller, which is in a way also middleware, but the controller is the last one and the controller sends the request. So let's go ahead and create this folder, middlewares, and we're gonna create a file. How did I call it? Validation middleware. Let's create the file here. Validation middleware.ts. I'm gonna bring the code here based on that blog, but it's a bit different. And I'm gonna actually go ahead and put it in the guide that you have access to so that you can copy paste it. I don't really want to write everything manually here. It's going to take a bit of time. So let me add here the source middlewares validation middleware.ts. One second, guys. I'm gonna show you where to take it from. So from the guide that you're gonna receive, if I reload it, under data validation with Zod, you have here this drop down, and you can copy the scheme, the validation, the middleware from here. So the actual middleware is this return function. So usually middleware has the request that we got, the response that we can use to pass or send responses, and the next function. If we call next, that means that, hey, go ahead and call the next middleware in the chain of middlewares or call the next controller. So here, what we do is we try to parse the schema. And if we manage to do that, that means that the data is valid. So we're going to call next. We're going to send it to the next one saying that, hey, everything is fine. Go ahead, use it. However, if I catch an error, we're going to check, is this a Zod error? If it's a Zod error, that means that it's a parsing, it's a data validation error. So what it's doing here, error of type unknown. Well, I still need to install Zod. So let me go ahead and install Zod now, because maybe the issue here is from Zod, and I'm going to continue explaining it, because installing Zod is a matter of cd API and then npm install Zod. So now, okay, now error is okay because it's an instance of this Zod error. So the error messages is going to be mapped and created from all the fields. So if there are errors on multiple fields, we're going to create a message that contains all of them. And we're going to send it here with the status code 400, meaning that it's a validation error. It's a client-side error. In the invalid data, and the details is going to be error message. Otherwise, it's going to be a status 500, meaning that something bad happened. I don't know what. Now, to use this middleware, we need a Zod schema. Let's go ahead and take this validation data middleware inside our routes products controller. Not in the products controller, but in the router, in the products index. Because that's where we can chain middlewares. For example, if before create product, we put here validate data, what happens is this is a middleware, it's going to execute, and only if it passes and only if it calls next, it's going to execute create product. If it fails, it's going to stop here. Let's go ahead and import validate middleware from this source. Like this, okay, like this. And it needs a Zod schema. I'm not going to complicate a lot. I'm just gonna go to the Zod documentation and see how we can define a schema just to test if things are working in a simple way. So with Zod, we can define a schema. Where is it? Basic usage. Let's basically import z from Zod, and let's say const create product schema is going to be z.object because we expect an object, and the type of this object is going to have the following fields. For example, the name is going to be z.string, the price is going to be z.number, and do I also have to do not null or required? No, I think it's optional, so if we don't specify optional, it's going to be required. So that's how we specify a Zod schema, and we can take this create product schema and give it to the validate data based on this schema. Now I'll point one more thing into the validation middleware, is that it takes the schema that we send it, will call the parse with a request body. So in a way, this is a validate body data, because we can have the same for validating query parameters. But again, I'll try not to super confuse you. So what will happen? Let's try to send this create product request for our Thunder client, create product. So if now I'm gonna send here an string to the price, it's going to say error invalid data. Remember, from validate data, invalid data, and the details contains the message. Details is an array. So the details is an array with all the error messages. Price is expected number, received string. And the error message is actually coming from the Zod, because we can specify here, if we provide here a string, that's going to be the error message. Let's say price should be a number. And if I'm not mistaken, do I have to provide here a string with message? I think so. An object with message, and this is going to be the error message. If now I will send the same request, the error message is going to be different. Price should be a number. Why is it price is? Price should be a number, because I specify price should be a number, but it has this prefix. I don't know. Oh, here, issue, path, and join, and is. Anyway, that's how we compose the error messages, but that's not the most important part. You can go and adjust here, like maybe you just do message, and that's going to be just the message. Price should be a number. Okay, so the first step is clear. We created hopefully it's clear. We created a middleware that can work with Zod schemas to parse and send errors if it fails to validate data, if it fails to validate request bodies based on the schema that it receives. Now, this is a very reusable one because we can use it in multiple places. For example, in validate data, here we specify the create product schema. In update data, we're going to provide another schema. And it's going to take this schema and we'll try to match the body to this schema. And if not, we'll compose a proper error message and send a 400 status code. Now, I was saying that I don't really want to redo this work. I don't want to recreate the schema again, even though it's probably not too complicated. If you have experience with Zod, like, it's going to probably make sense for you. But if you want to automate a bit this process, as I was showing you, we can look on Google for Drizzle Zod. And with Drizzle Zod, we can create Zod schemas from Drizzle and automate this part. Let's go ahead and install npm I Drizzle Zod. And what we're gonna do is, I'm still thinking where is the right place for the validation schemas. Because it's not part of a database, it's not part of a schema. It's part of a, let me do it in the router as I have it here. Like in the router, I have here create product schema. So let's see. We can create a schema using the create insert schema from Drizzle Zod. So let me do it here at the top. Create insert and create select schema from Drizzle Zod. And the create product schema, we're gonna create it using this helper. Create product schema equal to create insert schema based on the products table, right? Yeah. What's wrong here? Source database. Oh, but let's do it like this. Now this Zod is optional. Maybe we're gonna need it a bit later. But basically with this create insert schema, we created this Zod schema, which you see, it's a Zod object with ID, z.optional, z number, name string, description optional, image, price, and so on. So now if I'm going to go ahead here and create product and send the same request, we see price is expected number received string. If I do that, we see everything fine. If I forget name and send, we see name is required. So as you can see, it automatically creates these fields. Cool. Will the ID work if I send here ID 1? It's 500 error because in our validation, when I hovered over create product schema, I saw that it considered ID as optional. So it means that it can receive the ID. But in fact, the ID, because we specified it as generated always, that means that it's not going to be able to be set manually. It's always generated. And in the error message we get, which is 500, which means that we didn't handle it properly, we see column ID is a column defined as generate always. So we are trying to override it, which is not the case. So that means that in some cases, the schema that was automatically generated for us is not exactly what we want, but we can adjust it because this schema or this create insert schema will give us a Zod schema. And if you're going to look through the Zod documentation, you're going to see some helper functions like omit. So we can omit fields from a type. We can only pick a couple of fields from a type. And what I want to do here is I want to do dot omit, and I want to omit ID true. True is just saying like, yes, I want to omit it. Now, if I'm going to hover over this one, oh, it's still optional. Why? I was expecting it not to be not to be there at all. Let me double check something. What? That's very weird. In this case, it deleted when I added partial, but I don't want partial. Wait a second. What's going on here? ID is still there. Maybe it's not. Maybe it's not. Let me try to parse it to a type. Type product type equal z.infer. How is it called? Type og. Yeah, actually the type is not. Yeah. Now everything is good here. It works correctly. So the omit will omit this one, because if I hover here, I see that it doesn't have ID. And if I don't have ID in the omit, it's going to have ID here. So I want to omit ID from the create product schema because I don't want users to allow to send the ID. And now you would think that everything is going to work, but in fact, it's not going to work. Why? Because we're simply not validating it. We don't have any validation rules on the ID, but what we do next in our controller, we say, hey, request.body, or in the create product, request body, take everything that you got in the body and insert it into the table. So in a way, we are exposing here something that we are not expecting to expose. This is kind of a security issue because we are relying on the user to send anything in this body, and we're gonna blindly put it there. And if we forgot to add a validation rule on that, it's going to pass through it. So basically, without a validation rule, it's not gonna stop, it's gonna get here, and we're gonna put everything from request body. What I think would be a better option is to say, don't put the request body, put the data, put only the fields that we have in this product type, only those fields from the body that also are here in this product type. And that's going to work, I think, with a helper from the Lodash. Pick only fields from a type or something like this, from a Zod schema maybe. How to get a subset of JavaScript objects properties. Yeah, that's what I want. Using the destructuring, but I need that dynamically. So we have Zod get object with only fields from Zod schema or from a type. Extract object only fields declare type. Let's see. Remove object fields that are not in that type or in the Zod schema. You could create an instance of that class and iterate, okay, then you could strip away. I'm pretty sure there is with Lodash. I can hack it together, but I think with Lodash is easier. Omit, I think. You can approach it from the either an allow list or block list. Remove values you don't want with omit in Lodash. Very similar to how omit in schema or in TypeScript works. And here it's going to pick. So I'm going to only pick the ones that we have in our type or in our schema. And drop support for omit. Come on. Anyone has ideas? If I remember correctly, he said he'll keep it simple. Yeah, but I really want to solve some issues, because usually in a tutorial, what would happen is they will simply not show you this case. They will delete the ID here, and they'll say like, hey, look, everything works perfect. Validation works amazing. But you're gonna go in production, and there will be someone that will try to send an ID. And this is kind of a security issue that I'd like to properly solve it. And I didn't plan to solve it, but I don't want to leave you in this place. So what I will do, pick. Okay, Lodash pick. Let's go ahead. Let's install Lodash. And Lodash is a simple function that helps us to work with objects, with very common arrays and so on. So what I'm going to do is I'm going to first install in our API. Let's go ahead and do npm npii Lodash. And then I'm going to look for pick. And pick creates an object composed of a picked object properties. So from a body with any properties, I want to only pick the ones that are matching my type that I'm expecting and ignore everything else. For example, yeah, like this. So let's go ahead here in our routes, products controller. When we create a product, here instead of request body, let's do const new const data is going to equal to underscore, which should be imported from Lodash. Import underscore from Lodash. It also needs types, so let's do npm I save dev at types Lodash. That's going to provide the TypeScript for our Lodash. And if I go here and send the request body and say hold only the name and price fields, and if I'm gonna send the create product with this ID, it's going to work because it's going to, oh, it's not working. Oh, yeah, I know. Because in the products controller, I need to take this data and send it through to the values. Now, if I'm gonna send the create product, even though I send the ID here, it's going to drop it because I said I only need name and price. Now, the next step is to dynamically take this data based on in the routes, we have here product type. So based on this, either product type fields or the schema. Let me check something. Get type field type keys. So we can do keys. Oh no. Okay, get Zod schema keys. Schema.keys. Don't tell me, no. Oh, it's entries, it's schema.shape. Schema.shape. Let me look, I need this product type and product schema both here and in controller. So let me go ahead and add, not even sure where exactly. Maybe I'm gonna do export const here, create product schema. I don't need the type actually. And let's import create product schema in our controller. So import create product schema from index. Now we have this schema. We need to take the fields. So I can go ahead and do a console log create product schema dot shape. And what's that going to be? When I send a request, let me look here. Okay, it has price, image, description, name, and so on. So I will just take object.keys. And if I send another request, I should only see name, description, image, price. So now I can take these object keys and put it here. And everything should be working fine now. So if I send this data, it works. It ignores fields that we don't want here, like ID or let's say balance. I cannot change the balance of one account to something that that I want. So it will only work with the data that we specified in our validation in the create product schema. So let me stop for a second and think where I want to put this create product schema. First of all, I don't need the create products, the things that I commented out there. I don't need the Zod. I don't need this one. Where to put create product schema? Maybe I'm gonna actually move it to the database product schema together with a table. That's probably going to be a good place because here we have a table, here we have a schema that we expect when we want to create a product. And from index, we are going to import it from DB, from here. I'm going to remove products table. I'm going to remove this Zod. It's going to be much cleaner this way. And from the controller, create product schema will be imported from DB, from product schema, from here. And maybe I should do here maybe I should properly add a parser, right? A clean data. because having these low level peak object keys and so on here is not very nice. I'm thinking maybe at the middleware level to put it inside the request body as clean body. Because here it has schema. So let's see, because at this layer we can add things to the request that are going to be available later. For example, 1 second. Request.clean body, we can set it to equal to, I don't know, ABC. And now from our products controller, we can console log the request.clean body. And if I will look at the logs now and send this request, we see ABC here. So that way we know that we, from a middleware, we can assign new values to the request. So I think in the validation is where we parse, we validate, and we clean the body and put it into a new clean body object. So things that we have here in the controller that is doing this one, we're gonna put it in the validation middleware. We can do it like this. Clean body is equal to low dash peak request.body and only keep the schema dot shape. So it's going to work with any schema and it's going to clean the body to keep only the keys from that one. Now it's much better because here we don't have to do this stuff over and over again. We can access it by doing request.clean body. So if now I'm gonna send the same request, it's still gonna work perfectly, but it's at a much higher level at the validation layer. So it's working for everything. I don't have to do it over and over again. And the only thing that now is the problem is with TypeScript, because TypeScript doesn't know that a request from Express can have a clean body. This is additional fields that we are adding, and that is going to be, we're going to have to override the request type from Express and add some additional fields that we need in our application. We're going to do that by going into the source, creating a types folder, and here we're going to create the Express folder, and we're going to create a index.d.ts file for the declaration. That's where we put some declaration files. And I'm going to bring here this code. I'm going to also make sure to include it in the guide. So you have source types express index.t.ts, and here we're gonna put the extension of our express that will later have a user ID for authentication. We're gonna need that later, but now we're gonna have a clean body of type. That's gonna be interesting, like, I don't know, of type any. Let's go ahead and do clean body of type any for now. In the middleware, we can assign it here. And in the routes products here, we have access to it. It's of type any, but that's what we have right now. And the code for this express, you're gonna see in the guide. Okay, so now that we have worked quite a lot to set up this structure, later on it's going to be easier, I promise you. And I want to show that by adding the validation for our update route. So what do we have to do for that? We're gonna go into the database product schema, we're going to define a schema similar to create product schema, the one for update product schema. We're going to create it based on the products table, and we're going to simply omit the ID because we don't want to override the ID. You can also omit other things, like you don't want to override the price if that's the case, but I'm going to allow us to change anything except the ID. Now, having this product schema, I can go into our routes, products, index, where we have our router. I'm going to import this schema, update product schema from our database product schema, and I'm going to use the validate data middleware to say that, hey, validate data when you want to update using the update product schema. And that's it. That's everything that we need to do. Like, it was 3 lines of code that we needed to do to add validation rules for a new route. Now I will go into the Thunder client for update product. If I send a request right now, price is required because we have to do price 1, 2, 3, 4. Everything is okay. I can also add fields like ID that I'm not supposed to change, and because we worked on that system, it's going to simply ignore these items, which it doesn't. Because you know what? I know what. In the product controller, in the update product, we should not work with request body, but with request clean body. Now, if I'm going to do the same query, it's going to ignore the fields that we are not supposed to update. So I can safely remove it from here. And I will also remove a price and try to send the request again. We see price is required, but we want to be able to update only some fields, like a subset of fields. I'm going to go back into the product schema and the database. And when we create this update schema, I'm going to say that, hey, do it as partial, meaning that all the fields are optional. Now I can go ahead and send the same request, and it's going to work, and it's only going to use the fields that we specify. And if we specify a field, only then it's going to validate it. So if I specify a string here, it's going to validate and it's not a number. It can be a number, or it can be omitted because the update object is partial. It's all the fields are optional. Whew, that was intense, but I'm super happy with this system of using validation. I think it's very easy. Once you set it up, it doesn't have a lot of things, a middleware and some helper functions, but then it's super easy to validate data based on your Drizzle schemas. So let me go ahead and do a git add, git commit -m. Validations with Zod plus Drizzle schema. And let's do git push origin main. Perfecto. How are you guys? Still here? Did I confuse you too much with this one? I hope not. So we are at 121. Nice. How are you guys? So what is there left in our tutorial? I think I'm gonna close some of my tabs. I have too many opened. So we still have worder and worder items CRUD. We need authentication to log in, register, and then we need to deploy it to Genezio. I think I'm gonna skip the order and order items CRUD for a second. I'm gonna go and handle the authentication, the hard part, and then I'm gonna come to the CRUD because the CRUD part is not that complicated. It just takes a bit of time to create, read, update, delete, and so on, the order and order items. But authentication is something a bit more complicated, like not a lot of code to write, but I have to explain, and we don't have a lot of time. We have to move through it a bit faster. So I think I'm gonna take a 20-second break. We come back and we push through it to implement authentication, order CRUD, and deployment to production. So I'll be back and we continue. Look at this cutie. Hello. You were sleeping. Hello. Oh, let's go. Oh, that I'm very happy with how the API is turning out. Shah, hello, good to see you. Today I'm going to implement one of your live stream, but found a live. Thanks for a live stream. Perfect. What project are you following today? Could you do a nest.js tutorial next? We could look into it. Probably not in the next one, but I'm gonna look into it. We have an idea board where you can submit ideas so that we can, and if more people are interested, we can do that. It's on our GitHub. I'm not sure if we have a link in the description. Okay, it's quite intense. And we have a lot of things to do, and it stresses me out a bit. Okay, let's see. Hello, Sima from South Africa. We have a very nice South African restaurant here in Barcelona that I tried, and that was the first time I tried something like the South African cuisine, and it was delicious. Like I'd really love to go back. All right, guys, so let's start our authentication part. Yes. So what is the plan for the authentication? First, we need a database table where we're gonna store information about users. Information like the login, the password, which we're gonna hash, full name, and so on. Then we're gonna have to provide two endpoints, register and login. When registering, we're gonna insert an item in the database. When logging in, we're gonna try to find the item with that password. If it matches, we're gonna generate a token for that user. We're gonna give him the token, and then with that token, the user will be allowed to send other requests. Then we're gonna protect some of our endpoints to be only work for authenticated users based on that token. So all of these steps we're gonna do now. Let's go ahead and get started with the first one by creating that database for users. I'm gonna go into the source database, And here, let's go into let's create another file called users schema.ts. Similar to how a product schema was created, let's go ahead and start it like this. User schema, users table is equal to a PG table, and here we're going to provide the fields. The PG table should be imported from PG core. Yeah. Now here are the fields. For the ID, I'm going to use the same as in our product ID. It's going to be integer and auto-generated. Then we're going to have the information for authentication, such as the email and the password. The email is going to be a varchar of length 255. It's not null, not null. And also we can specify that it's unique. And this unique will add a constraint on our table to say that only unique emails can be in our database. Then the password is also varchar of length 255, not null. And that's it. Then for our role-based authentication, we're gonna also store the role of this user. This is going to be also varchar, length 255, and we can also say that it's not null, but it has a default value of user. Because if we do not provide like admin or seller, it's going to be a user. These are for, let's say, authentication. Then the user table will also have information for the UI, like the name, the address, and so on. Let's do varchar for the name, length 255. And maybe also an address because we're building a application for e-commerce. The address will be used for delivery. So that can be a text, like I don't know how long it can be, but it's going to be a text that will be imported from Drizzle as well. Not MySQL. Varchar and text from PG core. That's important. Here I forgot the comma, and that should be good. So email, password, role, name, address. I think that's good. Let's go ahead and now that we created the schema, I need to put it into the Drizzle config, because here we specify the product schema, but I'll have to specify another schema called users schema. Now let's go ahead and run the command npm run db generate to generate a new how's it called, migration. And we see a question: is email column in product table created or renamed from another column? I don't have, whoa. I see. If I go to user schema, I forgot to rename the table here to users. Let's go back and generate it again. Okay, it generated a new migration here. Let's go ahead and apply this migration by running npm run db migrate. That will apply the migrations. And if I'm gonna look at the Drizzle Studio reload, I'm gonna see that we have a users table, and I need to let Denchik go. Okay, you can go. He wanted to go outside. Now that we have a table, what do we need to do? We need to provide in the routes the authentication routes. So let's go ahead and create a folder called auth, and there we're gonna create the index.ts. We need to import a router from Express. We're gonna have to create a router using router, we're gonna have I got my coffee. We're gonna have to, well, let's just simply export. Is a default router? Yeah, let's do it like this. So this is going to be the auth router. We need to not forget to attach it to our whole application by going to the index from the source and doing import of routes from dot routes of index, and let's put it here under the URL called of routes. Now let's go back in our in here and provide the two endpoints that we're gonna need. As I said, we need two things. We need to log in and we need to register. So the first one is going to be, both of them will be post requests. So router.post to the /register is going to have request response like this, and we'll handle it here. To save a bit of time, I'm not gonna split it into a controller here because it doesn't have all 5 CRUD operation. It just has 2 requests. So I'm gonna do here post login request response and do something. Let's do response.send 200 and here as well. Okay, let's go ahead and find our client and make sure that we have in our collection in e-commerce here these of endpoints. They are going to be post, so yeah, I'll duplicate some of them from here. For example, this one. Maybe I'm gonna put it below at the end. Let's rename it to register, and this is going to be a post to /of/register. So again, from index.tsx we have auth, and from auth router we have register. So that's why we need /of/register. Now if I send here, we see 200. Okay, we don't have data yet, but it's okay. And I also have a same duplicate, the same rename login, and this one is going to be /of/login. Send. Okay, let's go back in our router and implement the logic of what should happen here. Hey Ajmal, thank you very much. Okay, so first of all, in the register, we need to validate the request similar to how we did it for the products. So let's go ahead in the user schema, do export const create user schema. We're gonna generate this schema using create insert schema from our users table. And we can also do omit ID, true, because we don't want users to send us the ID. And maybe the role is also something that we don't want the user to send us. And this is where our system to get rid of fields that we don't want was super important, because we don't want the user to send us the role because he can set him as an admin. That's why we put it here, omit role true. Now let's, while we're here, do the same for, I don't need to update the user, so I'm okay with create user schema only. Let's go back to in our auth routes. And here we can put the middleware validate data using the create user schema. Create user schema. Now here let's do console log request.clean body. Let's go ahead and send the register request and see the logs. I'm gonna open the logs here. Failed to run, cannot find source. Is that in our auth? Yes, it's here. So it should be like this. And it should be double dots, relative paths. Okay, now it's running and I can send the register request. We see the validation errors automatically with a couple of lines of code. That's amazing. Email is required, password is required. Let's go ahead and give here email and password. So email is going to be vadim@notjust.dev and password is going to be 123. If I send this one, we send OK, and the data that we send here is email and password. And if we send here name or full name, how did we say? Vadim, we see the name here. But if we are a bad guy and we want to say role admin, the role admin is not going to be here. We got rid of it. Perfect. Now let's go ahead and in the index, not in the authentication, we have a clean body here. Let's go ahead and what we have to do is const data equal body or request dot clean body. What we have to do is we have to we cannot store passwords in raw format. Password like this we cannot store in the database. We need to encrypt it. To encrypt it, we're gonna use the bcrypt.js library to encrypt the password. So let's go ahead and install bcrypt.js with npm install. I'm gonna do it here, clear. Let's import it at the top. I think it will also want types, so I can do npm I save dev types bcrypt.js. And we are going to say hashed password is equal to await. We're gonna do bcrypt.hash. And we are going to have the password, the data.password. And here we're going to provide the salt. This function became async automatically. So in your case, you have to add it manually. And now if I do console log data and then the hashed password, and when I do register, it's going to, if I do register again, it's going to have like this string. This is the hashed version of our password. This is a one-way encryption, which means that there is no way to decrypt from this string. There is no way to decrypt the password. But when we are going to log in, we're going to encrypt it, the data that the user sends us, and we're going to compare it if it matches the data from the database. So that's a strategy not to store passwords in the clean format in the database. Now that we have this one, we have the data, what we're going to do is we are going to insert it into the database. So let's do await db from like this /index dot insert inside the users table. So let's do users table. Where is it? It was imported here, users table. The values, everything data and the password is going to be the hashed password. Maybe you could also do data.password equal to this one. So you just get rid of a password altogether and you simply save the data values because it already overridden the previous password. And let's do here returning, and the user that we created, we're gonna say response.201, and the JSON, let's do here the user information, user. Now I'm gonna put everything into a try catch because things can happen. And in the catch, I'm going to simply send response.status 500. Something went wrong. Okay, let's go ahead and test it. If I go into the register and send this information, we see created. But no JSON. I was expecting the user, but it's not there. Let's see in our table, in our database here, through the studio, if it inserted the item. Yes, indeed, it inserted with a hashed password with role user, name Vadim. But why didn't it have the data in the response? Oh, because I did here send. I need to do status if I want to send something. So status 200 and then JSON user. So now if I'm gonna do register again, it's gonna tell me something went wrong because there was a user with that password, with that email. So I need a unique email. I need Vadim1. If I do that, now we have user with this data. Perfect. So creating a user works. The /register works. Now it's time to do the /login. The /login, let's go ahead in our user schema and let's create here a login schema based on this one, based on user table. But in this case, I'm not going to omit, but I'm going to pick some values because I only want the email and the password. So only two fields from where I want it, the email and password. I'm gonna go ahead and use the login schema in our controller, and I'm gonna add it in as a middleware here, validate data, login schema. Now we can add the try catch easily. Try catch, and here in the try I'm gonna get data equal to request.cleanBody, and in fact I can right away destructure email and password because I'm sure that it's there, because if it passed the validation it's going to be there because they are required on our table. So I can do console log email and password to double check if it works. So I'm gonna go into the login. I'm gonna take email and password from here to the login. And even if you provide like other information like balance and so on, it doesn't care. It's just going to keep email and password based on that schema. So email, password, it's here. Now what we have to do is, well, we need as well to do hashed password. It's going to be the same method as we did before. Await, which makes this function async, bcrypt hash password. So let's do just password with the same salt value. But there is also another step before which might fail. So what I'm going to do is I'm going to fetch a user by this email. So let's go ahead and do user is database dot. Let's query the database. Database dot select from users table. Oh, I need select then dot from users table dot equal, come on, no, not equal, but where equal users table dot email, where it is equal to the email from our body that was sent. Now, if there is no user, that means that there is no user with that email. So I'm going to simply send a status code 401, and I'm going to say authentication failed. Another important thing, don't provide too much details here. Don't say user with that email does not exist. Just say authentication failed. Because if you provide more information, bad people, hackers, will know like what happened. Is the password wrong or is the email wrong? And it will go ahead and continue trying to go around it. So if there is no user with that email, authentication failed. Now we're going to hash a password, and that means that there is a user with that email. So what we're going to do is we're going to check if the user.password, which is already hashed, is different than the hash password. That means that the passwords do not match. So I'm going to do the same thing. Authentication failed. Otherwise, we need to create a JWT token and give it to the user. So here, that means that the authentication passed. There is a user with that email and the password is correct. Should we send back the hash password to the client in JSON? That's a good point. We shouldn't. So here in the user, in the register password to user, probably I should do const. Can I do remove user.password? Password egal. I don't know. I can override it like this. And if I do 2, it's going to be empty. Probably it's better like if you completely ignore it. My mind is not minding right now to remove it from here. Yeah, for some reason, no, it's, or maybe undefined, but no, it's still going to be there, but with undefined. Free. Oh no, it's not there. So if I just do undefined, it's resetting it basically. Okay, perfect. Back to keyword delete. Yeah, not remove, but delete. So delete. But delete operand must be optional. The operand of delete operand must be optional. It doesn't like it because yeah, I should do const clean user equal to user and then delete clean user. Still doesn't want. Like I need the TypeScript is not happy because password is required. I will do TS ignore for here. So where are we? Here we've created a JWT token. So what do we need to do? Basically, now that the user logged in and we know that he's logged in, we need to make sure that some request, for example, creating a product, is only able to be done by a user that is logged in. For that reason, the user will either have to send us the email and password with every single request, and we're going to have to do that to check that like this, or we create a token, we give that token to the user, and we say, every time you want to send us a request, give us that token, and we're going to know that you are authenticated. And to do that, we're going to use JSON Web Token. We're going to encode some data into a token. And we're going to give it to the user. Then we're going to decode it and make sure that it's a authenticated user. So let's go ahead and start by installing this JSON Web Token. For short, you probably heard it a lot, JWT, but for long it's JSON install install JSON Web Token. Let's go ahead and import it. Import JWT from JSON Web Token. And it also wants types. These are optional, but if you install them, it's going to be strictly typed. It's going to provide better. Okay, now with this JWT in the /login, what we can do is we can generate this token using JWT.sign, and we're gonna sign an object with data that we want to be there. For example, I want there to be user ID, or you can actually put the whole user there. But for now, I'm gonna do just user ID, user.id, and maybe even the role. So role, user.role. And the second parameter is going to be the secret, a secret string that is used to sign, to basically encrypt and decrypt data. So here I'm gonna do your secret, but you actually need to do it as a secret, probably through environment variables. But I'm gonna leave it like this because I'm running out of time. And the last one is the options, and in the options you can do the when this token should expire. So you can do, I don't know, 12 hours or something like that, or 30 days. Will 30D work? Maybe. Now we can take this token and we can send it back to the user. So response.status 200.json token. Or maybe let's also do user and token. User and token. But in this case, user will also have a hashed password, right? So let's do it like this. Let's again remove a password and send the token and the user. Now if I'm gonna go to the login and try to log in with Vadim1, what we see is authentication failed. Why? I don't know. In register, I'm gonna do Vadim5 and password 123. Register, and then I'm gonna try to log in with Vadim5. Authentication failed. Authentication failed. Did anyone see the problem? Is it here? Console log user. Let's see what is the user when we call send. The user is correct. So it shouldn't be here because there is a user. Is it here? Let's console log here two things. Oh, password. Let's console log user.password and hashed password. Maybe in two different lines so we can compare them easily. Because it's here, so password is not matching. Authentication failed. As you can see, they're different, but why? Oh yeah, I can do const password and other. Yeah, I can destructure. That's true. That's very smart. But another problem is why the password is different. Can anyone help? Does anyone see the issue? Password with salt 10. Can it be password 123? Password 123. What? Password, cached password, user password. Console log. Let's do actually password, and maybe even password length. Use compare. Oh, yeah. Yes. My bad. My bad. Yeah, the comparing part shouldn't be done like this. For some reason, I was mistaken. The way we compare it is using bcrypt.compare. And here we send the password, like the two values that we want to compare. So the password and the password that we receive through the body, and the user dot password. And here matched. So if it didn't match, then authentication fail. So now if I'm gonna change the password to not match, it's going to be authentication fail. But if I'm gonna go back to 1, 2, 3, it should be okay. I get back the user without the password and the token that I can use later to send the other requests. Okay, thank you very much in the chat. That saved me some time. And now the last step that I actually have to do here is going to be the middleware, right? Now that a user has this token, what I want to do is I want to say, whenever you create a product, I want only authenticated users to be able to do that, and maybe even add some role-based authorization to only sellers to be able to create a product, not anyone. So for that, we need a middleware, and we need a middleware called of middleware.ts. So let's export function, a verify token function with request of type request from Next.js. I'm gonna look at the other validation middleware to use the imports, response, and next function. So the token, we're gonna take it from the authorization header. So token, we're gonna take it from request.headers or header, and let's get it from authorization. Yep. Now, if there is no token, then we should stop here, and we're gonna return response.401 status 401 and error access denied. And let's do a return here to stop the execution. If there is a token, we're gonna do a try catch here. If catch happens, again, we're gonna do a response 401. But in the try, what we need to do is we need to decode JWT token data. So let's go ahead and import JWT from JSON Web Token. And const decoded is going to equal to JWT.verify. The previous function was sign, now we verify. We verify the token, and we pass here the same secret that we used when we created the token. So in the route of index, we used the secret which was not very secret, but anyway, it was a secret called your secret. So let's use the same string as a secret to be able to decode the data. Now let's go ahead and do a console log decoded. And simply do next, because for now I want to pass the request to the next one. Now let's go ahead and add this verify token on some of our routes. For example, in the products index, I want to do a router post only if you are authenticated. So I'm gonna add here, even before validating the data, I need to make sure that the user is authenticated. So I'm gonna put here verify token imported from our newly created middleware function, which should be middleware. But it's not a function, so it's just like verify token. It's just the verify token is the actual function. So now if I'm gonna go and do a post request there, if I'm gonna do funder client, create product, and I'm gonna send it here, we see access denied. Why? Because we didn't even provide the token. If I'm gonna go to the login, send the login, and copy this token, go back to create product, in the auth, use a not basic. I'm not sure if it's better. Let's try this one, but probably it's not. No. Let's simply do a headers here of authorization. And the value is going to be our token. If I send it, we get past that checks, and in the console log where we console log the decoded JWT token, we see user ID 7, role user, and here is the expiration time and so on. So what we can do now is we can check if we manage to decode it, and if it's an object with user ID, everything good, go ahead, continue. If not, for example, if type of decoded is not object, or there is no decoded dot user ID, that means there is no user, so I can do the same response for one and return here. Otherwise, go ahead, go to the next part, but I will attach to our request object the user ID decoded dot user ID, because later it's going to be easy for me to take this user ID. For example, in the product index, when creating a product, we are passing it through the verify token. So I can go in the create product controller, and in the request, I'm gonna have here console log request.user ID. And what I can do with it is I can assign the product that we create now to the user that is making the request. So request, if I go to create a product and send it, we see user with ID 7, because that's the token of a user that it belongs to. And if we provide an invalid token, we're gonna see access denied. So from login, I'm gonna copy the token, put it back here, and we can now create tokens. And the same of middleware, you can add another one for the role-based middleware. For example, you can have another one. I'm going to duplicate a lot of code, but I'm going to have one verify seller, and only allow requests from the users that have a role seller. So I'm gonna do here if decoded dot role is not seller, let's also stop here. There is a better way to do it, but anyway. So if it's not seller, you don't have access. Not as seller. So if I take this verify seller into the products controller, into the index, and after verifying the token to make sure that we authenticate user, we are going to verify seller, which is the authorization. So let's import it as well. First one, we just make sure that the user is the one who he's telling it to be, authentication. The next one is authorization. We only allow sellers to do this request. And if I'm gonna go ahead and try through the client to do create product and send this request there, you are not a seller. But if manually through the Drizzle Studio, I'm gonna go ahead to the user with ID 7. And if I'm going to say that the role is seller, save change, it's still not gonna work because my token doesn't have the data. So I need to log in again. It's going to generate new token. I will take this token in the create product authorization. And now I'm supposed to be allowed to do that because now my role is seller. So this is the auth middleware, which probably it should be done a bit better. Maybe in the first one where we verify token, we're gonna also put request.role as decoded.role. And from here, I don't need to decode it again. I can just check role request.role, and I can say if, where is it? If role is not seller, then access denied. Otherwise, just do next. So it's a much simpler function because we don't have to decode the token over and over again. And I'm gonna put this role on our types express here as a string. And now if I try again, create product, if I do send access denied, why of middleware, if role is not seller, stop here, otherwise do next. Or maybe it should be the other way around, but it's the same. Now it's going to allow me because I'm a seller. Perfect. Okay, and it works on building up on top of another middleware. So now things that we want to protect only for authenticated users will only receive this verified token. But if you also want to make sure that that user is a seller, you can add verify seller. And you can do another function, verify admin, which will check the role if it's admin or not. So that's how you do authorization. And with that, I think we are good here. Maybe I'm gonna put the same verify token and verify seller for the put and to the delete as well. Verify token, verify seller, and list products and get product by ID. Anyone can do it. I think even guest users should be allowed to do that. If you don't want guest users to be allowed to do that, you put only the verify token here. And that's another reason why we extracted the controller out of here, because here is where we just compose like all the middlewares together, and we don't want to have a lot of code here. We just have a high level view of what middlewares we have until we get to the controller itself. Now I think we are done with authentication. It took a little bit longer than I expected, but I'm happy with the result. So I can do authentication, and authorization, and git push origin main. Perfect. So we are a little bit, we don't have a lot of time left. And what I wanted to do now is I wanted to see if I can build this project and if it will run properly. So in the package.json, I have a build script here. Let's go ahead and do npm run build. That will generate, that will build all the source files into the dist folder. And here we have GS files. Let me try to execute this index.js because that's the entry point. That's our express entry point. So if I do here node dist source index.js, we're gonna have an error saying that module not found. Product index, yep. The problem is that in index.js that we build here, when we are importing these files, JavaScript files are not imported like this. In JavaScript, we have to do .js, like we have to specify the extension. There are tools and there are ways of how we can do this automatically, but we don't have them. We're not gonna do that right now. What we are gonna do to solve this issue so that we can run the distribution is we're gonna add to all the imported files in our application a .js extension. Did I do git status? Yes. So let's start with index. We have here .js, we have here .js. Let's go from the database, from the top, database index. We do not have any local files, product schema, no local files, schema. We have here .product schema.js, user schema, and we are editing in the source folder. That's very important. We are never editing the dist folder. So it seems a bit weird because we are referencing TypeScript file, but we are using JS extension. That's because TypeScript will know that, but JavaScript is a bit dumber, and we need to say to conform with JavaScript rules. Going to the user schema, we don't have any local files. Let's go to the next one, middlewares, authentication. Nothing here. In the routes of index, we have the user schema.js. We have middleware.js. We have index.js, and that's it. Now in the orders, we don't have orders yet, but in the products index, we have product controller.js. We have middleware.js. We have product schema.js, and we have .js. Now in the controller, database index.js, create product schema not needed, but this one is .js. And that's it. In the types, nothing is there. So that's everything that we needed here. We make sure all the local files that we have, the relative path to our local files, have a extension .js. Now if I'm gonna do npm run build again and try to run the index.js file, we have another problem because it's already in use. I need to stop the development server and try to do it again. And the application is listening, which we can try to do here with login, for example. Something went wrong. Huh? Why something went wrong? Something went wrong. Register? Something went wrong. It's localhost, port 3000. List products. Internal server error. What's happening there? Oh, it's not using the environment variables. So no worries. Everything is good. It's just not using the environment variables. You just need to specify it here with env file like this. It's just a matter of environment variables. If I do that here and do now list products, it's still not working. Not really nice. Index.dist index.js. Source index. It should be source index. This index. Where are you coming from? Dist source index. So if I do slash, will it work? What's gonna happen with a slash? Hello world. But if I do slash products, let me do routes products controller. In the list products, let's do console log error just to see if we can find it. I'm gonna rebuild it and I'm gonna run it. And maybe the .env should be before, you know? Yeah, maybe. That's true. Most probably the .env should be before. So now it's listening. I'm gonna try blindly to send a login request. And it's working. Perfect. So now our distribution, when we build our application from TypeScript to JavaScript, it's working as well. So I can go ahead and stop it, and I can do git status, git add, git commit -m. And this was fix TypeScript build. Perfect. And now that we have our distribution working, the JavaScript distribution working, now it is time to learn how we can deploy this API so that it's going to be publicly available anywhere. And that's where, guys, Genezio is helping us do that. With Genezio, not only can we create serverless functions as you would be able to do with AWS Lambda, but in a faster way without the cold start problem. Another benefit is that we can deploy frameworks such as Express. So it's very simple to take an Express application and deploy it as a serverless function without having to worry about servers, without having to worry about anything. So all we have to do is, probably we're going to go into the documentation. Under the frameworks, under Express.js, and follow this documentation. Let's go ahead and first install the Genezio CLI globally. So I'm going to run npm install genezio-g to install it globally. Then we need the Express.js application. We already have one. Now we need to install the serverless HTTP. This is a small package that exposes a serverless endpoint. So I'm going to make sure that I'm in the API directory, and then I'm going to install serverless HTTP. Now I need to simply wrap my application inside a serverless function. So let's import serverless HTTP in our source index at the top. We import serverless. We go ahead and we export a handler. So export const handler, our application wrapped around serverless like this. Now that we are exporting this handler, we will be able to attach it and run it as a serverless function. The only thing is that in production, we don't have to listen. So I'm going to do here, if process env is dev, So if it's dev, then listen, otherwise just simply export the serverless application. That's it we have to do here. Next, we need to make sure that our type module in package.json, but we already have that in package.json type module. We now need to create the configuration file for Genezio. This is a small file that tells Genezio how do we want to deploy our application. I'm going to copy this one, and I'm not going to put it in the API folder. I'm going to put it in the root folder of our whole project, because with Genezio we can both host backends, frontends, and multiple applications. So let's go ahead and create this file here called Genezio YAML besides our API, and start with this example. Let's start with this example. And what do we have here? This is the name of our application. Let's go ahead and give it full stack ecommerce. Ecommerce. For the region, I'm going to do EU Central 1. You can leave the one that is default there. For the version, I'm going to leave 2. The path, root directory of the backend. So the backend is at /API. So this is the root directory. The language is JavaScript, and here package manager is npm. The only thing that I'm going to add here is the scripts that will tell what scripts to run whenever we deploy. So for example, when we deploy, I want to do npm install and maybe even npm build, because I'm not sure if the build directory is going to be there. So the scripts deploy, but it's not here in the language. So I need scripts to move it back. So scripts is right inside the backend. And there is also the local way of running it, but I'm not going to do it. So just that, it's enough. npm run build. Now the next step is the function, our edge function, our Lambda function. We call it hello world express application function. Let's do it ecom API express or ecom express API function. This is how we're going to see it in our dashboard. The path to the function is going to be the root directory of our API folder, and the handler is going to be handler. But the entry, the file, is going to be dist source index. So it's going to be dist/source/index.js. So with this in place, I think we are ready to go ahead and deploy our backend. If I'm going to scroll down, we can test our application locally, or we can go ahead and run Genezio deploy to deploy this project. I'm gonna do cd dot to move to the root folder, so that where Genezio YAML file is, and I'm gonna run Genezio deploy. Let's see if I didn't make any mistakes here. If this is the first time, it's going to simply open up a window to a browser window to authenticate. Now it's asking that we see a database URL set remotely. Do you want to set it for you? Let's do yes, and this will automatically probably take it from the environment and set it there. Now we see that everything was deployed successfully. If I'm gonna go back to my Genezio dashboard, in the dashboard, beside the database, under the project, we see full stack e-commerce. If I open it up, we're gonna see a function. Function has a URL. If I copy this URL and I send a request here, if everything works correctly, we see hello world. If I'm gonna do the URL/products, that's going to be a list of products from the database. And as you can see, now this is a backend hosted on Genezio, accessible anywhere, served in a serverless way using the Genezio cloud. with a really, really low cold start timing. So super performant, and also with everything that you are familiar with already, like Express framework, Node.js, and so on. So now everything that we had locally working, it's working here. I just did products, but you can create products. You can, and you can see that if I copy this URL and go to the Thunder client and say, I want to log in, come on, log in to not localhost, but I'm gonna paste here the URL of my API, of my function on Genezio. If I send this request, I cannot post because I need to do, I had 2 slashes. If I do it again, we have a token, I can take the token, and I can do other requests as well. So as you can see, everything is working and is deployed to production on Genezio. For the logs, you can go to Genezio dashboard here under logs. You're gonna see the logs of the functions. This is the function called, it's status code 200. You can have more information and the invocation details like this. You can test your API through the dashboard as well by selecting the function and by sending requests. You get responses here. You can handle the environment variables, and you can also integrate it with your GitHub. So every time you deploy to GitHub, it will automatically deploy to Genezio. They offer that in the documentation. If you're gonna look, the GitHub CI/CD should be GitHub action here. You can create this GitHub action, and every time you submit, you do git push to new changes, it will automatically deploy. So if I do git status, I'm gonna do git add and do git commit -m deploy to Genezio. Perfect. And git push origin main. Tammy is saying absolutely awesome. Thank you very much. I appreciate it. All right, so that was our deployment, way easier than expected. And that is more or less the tutorial that I prepared for you. But there is one important thing. There is the orders and order items CRUD that we didn't manage to implement today. So what do we do? Because the next time we go live, we're gonna do the mobile application. So let me go ahead and build these orders and order items in a quite fast way, because it's going to be very similar to how we handle the products. The strategy is going to be, we create the tables, we create the CRUD operations, we insert into the tables, and so on. And maybe I'm going to even copy paste some code. So let's figure this out because we're gonna need it later, so I'd rather do it now and spend a little bit more time. Let's go ahead in our database. We're gonna add a new schema for our orders.ts. This is going to be our orders schema. Let's figure out what's going to be our orders data. The order table, this is going to be our order table. So I'm just going to mostly comment out what I'm doing, but I'm not gonna try to type everything myself for the orders, but I'm gonna stop for things that are important and that are new. But creating a table we already saw for products and for users. Now we create PG table. Timestamp is a new field from PG that will allow us to use timestamps. And we have created that because we would love to know when the order was placed, and we default it to the current time when we insert something. Here is something new. Here we have user ID that will reference the user ID from the users table. Now we get into the relationships. So we need to import user schema and make sure to do user schema.js. And the user ID is of type integer and it references a user table ID because we want to link a worder to a user. Who is the user that created the worder? But a worder will also have products. So speaking about relationships, the relationship between a worder and a user is one-to-many. And usually you define this one-to-many or many-to-many by asking a couple of questions. First of all, how many orders can a user place? Well, he can place many orders. So we have the first one, many. And we reverse the order. How many users can place one order? A order is placed by one user. It belongs to a user. So here is a one-to-many relationship. And a one-to-many relationship is quite easy to implement because we simply put on the, for example, orders table, a reference to the user. And in this case, order has only one user, but user can have multiple orders. Now the question is, how do we handle many-to-many relationship? Because let's ask the same questions between orders and products. How many products can a order have? A order can have many products. In how many orders can one product be? One product can be in many orders. So here we have many-to-many. A many-to-many relationship cannot be created without additional things. What we need is one more table that connects them between each other. So that's why we need here the order items table, PG table, order items, that will create this relationship between orders and items. And here are the fields. We generate an ID and it will contain two references in two different directions. A reference to the order that this item is and a reference to the product that we are referencing. Let's import products table because it's also a reference. And in this relationship, we can store additional information like the quantity. How many of this product are we ordering? And the price. I added price here because the price on the product itself can change. So we are not going to be sure, like we cannot depend on the price from a product, which can change over time. We need to know what was the price when we created the order. So that's why we're going to duplicate it here and never change it in this table to be able to calculate the amount. Okay, we have a orders table. We have a here. What we need to do is we need the type for inserting a order. So insert order schema, we're gonna generate with this create schema from Drizzle Zod based on orders table. We want to insert a order. And obviously you can do here the omit stuff, like we don't want to do ID true. What else? ID. The user ID is not something that we want the user to specify. We're going to take it automatically from his authentication header. So I'm going to omit the user ID as well. Status is not something that I want the user to allow to change. I think, but maybe, no. I will allow, maybe not when you insert it. So status true. Created that, also not something that I want to allow him to change. So it's actually pretty nothing. You just insert a order. It's just information about, hey, here is the order. Indeed, it's nothing. Maybe if you have like other fields where the user can specify about the order, like, I don't know, when he wants to receive it, if it's a choice, then it's going to work. But for us, like, it's not gonna have any fields. So the next step is I actually want, through the same request, I want to insert order with items all together. So what I'm going to do is I'm gonna create another field called insert order with items. Create insert schema orders table. I will not do that. I will do insert order schema. No, I think I haven't done it like this way. Let's take it step by step. I'm trying to jump too far ahead. I have insert order schema. Let's go ahead and define our routes for orders. So we're gonna have index.ts here. We're gonna need the router. We're going to need the CRUD operations, and then we're gonna export default router that we're gonna create here. Router equal router. Now we need to make sure to assign the router here to the application.use / orders orders routes. Let's do here orders and call it order routes. Orders routes. We're gonna put it here. So in the orders routes, first we are going to, let's go ahead and also set up our controllers. And the controller will start with a create order function. Let's assign this create order in our router for router.post request. On the / we're going to create order that should be imported from the controller.js. Create order. And we should just simply say, I don't know, try something and catch error invalid order data response status. Oh, I need to import request response from Express. So now what can we do? Now I will also add some validation rules. So on the orders, let's add this validate data. The data is going to be based on the insert order schema. And now in the controller, I should have access to the console log request dot clean body. Now, if I go ahead here and maybe duplicate this post request and move it up, where is it? Create product. I don't see it, I lost it. Create product copy. At the top, rename it to create order and change it to orders here. If I'm gonna send some data, error, connection refused because I need to run the server. Let's go ahead in the API and do npm run dev. If I send the same request, send request, connection refuse, localhost 3000. Should be 3000. Node completed running. Maybe, yeah. I need to, now when I do dev, in the package.json, I need to set that environment is dev. Because we have that, we added a new check there. And where is it? Express node env dev. In the package, before we run node, we're gonna set the environment to dev. Now let's try it again. Now it's listening, so I can do create order, paste, and it's processing. Probably nothing is gonna happen because we are not sending a response yet in the orders controller, but we are console logging the clean body. So we have empty string here because that's what we have in the information in the request body, in the data that we expect. The thing is that we already can create an order. So let's go ahead and do that, because for a order, we actually don't need anything. We're gonna do const. Let me check something. Const order equal to await. Do it like this. Await db dot insert. Let's import db. db slash index.js. So we're gonna insert in the orders table the values, for now, empty. Let's import orders table. Boom, 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 boom. Okay. Values empty. Well, we need user ID here. The user ID can be taken from user ID is equal to request dot user ID. So let's do user ID. But in order to have a request user ID, we need to make sure that in our orders router, besides validating the data, we should also have the authentication middleware. Validate, how is it called? Middleware of verify token. So we need only authenticated users to be able to send a request. Oh, come on. Place an order, I mean. I'm rushing and I'm making silly mistakes. So now verify token is going to add that user ID. So when we get to the create order, we're going to have that request user ID. We have here values. Okay. Not sure why it's user ID integer. Oh yeah, because user ID here is probably a number or undefined. And yeah, I'm gonna do if user ID is not here, then invalid data. Yeah, something like that. Now let's do returning console log order. Let's go ahead and open and see the terminal, and let's try to send the create order. We see empty, invalid order data. That's because in our authentication header, or in the headers, we do not have authorization. No, actually we do have. But what's the problem? Invalid order data. Invalid order data, invalid order data. Headers, authorization. Let me try to log in again, maybe. send login, get the token, and then create order, authorization. Let's put the token and send it again. Still invalid data. Why? In our index, we have a verified token, similar to how in products we have here a verified token. That means that it should add that one there, invalid data, products, orders, console log, user ID. 7. So user ID is there. Maybe it got here, so I will do console log, yeah, console log error to see what's going on here actually. Create order. We see parsing error, something, orders does not exist. Okay, I know why. Because we created the Drizzle, the database schema for orders and for order items, but we didn't run the migration. So what we have to do is we have to do npm run db generate to generate the migration, but we should be in our API folder. Generate. Okay, now we need to migrate. Now we created the orders and order items table. We can verify that through the Drizzle Studio if it's still running. It's not there. Why? 2 tables. Oh, I know why. In the Drizzle config, we need to also put the schema for our orders. So as you can see, trying to be faster is not actually working as I intended it to be. So let's now do migrate. Did it create? No. Generate 2 tables. Why is it still 2 tables? Source db should be order schema, right? Yeah, schema. Let's do order schema. And now migrate, not migrate, but generate first. Can find user schema. From where? From where user schema can find. Orders schema. Hello, Daniel. Yeah, I'm finishing the last things. I need to do it. What's happening here in the Drizzle config? Source database orders schema. Is it correct? It's orders schema. And if I try now to do generate, it says Drizzle kit cannot find user schema.js. Why is it JS? Who said about JS? Cannot find user schema.js. Nobody said JS. Product schema, user schema. Oh, here. Oh boy. Oh, that's not very good. Because in this case, it cannot find it. So I'm going to have to remove this JS just to run the migration. But then I'm going to probably have to bring it back for it to work in production before we build. So let's do migrate. But I will bring it back, the JS here, even though the migrations are not working with this one. That's a bit weird. But now I have the tables, users, orders and order items. And I can go ahead and send the create order request, and the response is this one. It was created with status new. And if in orders I'm gonna go, we see new order just created. Perfect. But besides this, I'll want to, in the body, what I want to do is I want to send here some information about order if needed, but for now there is no information about order. But here I want the items, to include the items that I want to insert. For example, I want an array of items where product ID 1, quantity 1, price this one, product ID 3, and so on. Let me just double check if we have these products with these IDs. We don't have one, so I'm gonna do 2, product ID 2 and product ID 3. So now I want to take these items here and add them in the order items table. But if I'm gonna send it like this, I'm not gonna receive the information in my orders controller in the clean body. That's because of the validation that we have used. So let's go into the order schema and adjust a little bit our insert order schema, or create a new one. Oh boy. Let's create, where is it? Let me double check. Insert order with items schema. So we're gonna create a new schema here. Where is it? In the orders schema. I'm gonna create a new Zod schema by importing Zod from order, which will reference this schema, and items, which is going to be an array of insert order item schema that I have to define here. Export const equal to create insert schema based on order items, and probably we're gonna have to also omit some stuff from there, such as ID true and so on. But at least we're gonna be able to do order ID, product item, and so on. So now we have a schema with two fields, order and items. Let's use this one in our validate data. Let's import it from here. And let's go into the orders controller and see the clean body that we're gonna receive now when we're gonna send this create order request. It's not like this. Where is it? So we send both order and items. Bad request, because what? At the end, it's not a valid JSON. Do you see where it's not a valid JSON? Send, bad request. Expected comma or after value 35. Order items 1, product ID, quantity ID. What's wrong with this one? Validate JSON. It's valid. Is it in the middleware? Validate middleware. Is it here? Try catch internal server error. No, it's bad request. Oh, invalid data. Item 0 order ID is required. Oh, yes, it's the validation. So let's go ahead, because order ID is something that we don't specify here. It's going to be taken by creating a new order. So in order schema, we want to omit from the items the possibility of sending the order ID. So we're gonna omit it. It's telling me exactly what it's supposed to do. So now if I send it, it's processing, and I have all of this data here, order, and the items that we need to insert. Okay, now in the orders controller, after we create this order, what we need to do is we need to loop through the items and insert them in the table. So what we're gonna do is we're gonna do await database.insert into the order items table. The values, we can send here an array of values. And the order items, we're gonna create them here by mapping for all the items from our request clean body. Where is the? Let's take from request clean body here. Let's destructure the order and items equal. Here I'm gonna call new order and items. Did you mean item? No, items. Map through them and add order ID for all of them. So everything that the user said, just put the order ID from the new order ID. And we're gonna insert in the table these items here. And let's do returning. And const items equal to await new order items. Let's now try to send this information to the user as a response dot status 201 for created. The JSON, we're gonna put everything from the new order, and we're gonna add items there as new order items, which should be an array. I don't know, let's give it a try. So if I now do create order and send this request, we receive back the order with ID 3, status new, from user 7 with this item. Order ID 3, it links to this one, product ID 2, order ID 3, product ID 3, with quantity and with a price that we specified here. Probably a better way would be to go ahead and not allow users to send the price, but pick it manually from the database based on the product ID and add additional validations for the, for example, here, where is it? Order items. Validate product IDs and take their actual price from DB. That would be a to-do before we store the order items in the table. But now that's it. Now we have them in our table as orders with information about the items. For example, this one has 2 items. This is the product and this is the order. Perfecto. So we can store orders What would be another request that we must implement? Let's do git status, git add, git commit -m orders, and order items create. Okay, so what else? What else? I think it's important, besides creating an order, to list the orders, right? So listing the orders is actually not that complicated. In the order controller, let's move here. And listing the orders is just going to be a matter of doing database select from orders table. And we take all the orders here. Maybe later we can add filtering to list orders based on user ID. But for now, I'm just going to do it like this. I'm going to go to the router and I'm going to say router dot get. When we request the slash, we're going to get a list of orders. And I think we need to verify the token. We don't need to validate any data, and we just do list orders. And in the list orders, probably we should do if role is admin, return all orders, else return only orders filtered by request.user_id. So you can check request role. If request.role is admin, just return all orders, otherwise order by ID. Or if request.role is a seller, return orders. We actually don't have this functionality. We need to link the order to a seller. So this is not really possible now, but this one is possible to return user-generated, user-owned orders. So in the index here, we verify the token and we list the orders. Now let's go ahead and test this one out. If I'm gonna go in the, I'm gonna create a new request to /orders, localhost /orders, access denied, because we need a header. Let me do from authorization. I'm gonna take this one. I'm gonna do here authorization, and I'm gonna paste the value, and I'm gonna send it. Now we get a list of orders. So first order, second, third. Perfect. List of order is not very complicated. Getting order by ID, that's a bit more interesting. And here is where, let's do getting order by ID. I'm gonna put the code here. In this case, we're gonna work with relationships, like with items. So by doing the SQL-like method with db select, we're gonna have to do some merges. But we can use the query API, so we can do db query, orders table, and we can manage them here. But this requires some changes, so I'm not sure if I really want to do the query API. I don't think I'm gonna do the query API. Let me do I'm not gonna do query API now. I will remove like this. So what I'm going to do is let's start by fetching the orders. db select from orders table, where the ID of orders table.id is equal to this ID. So let's import equal. Equal should be imported from Drizzle or RAM. Okay, where is it? Get order, orders. Not orders, but should be order. If result order not found, if order, otherwise return order. Perfect. Let's go ahead here and say, give me the order with ID 3, the one that has items. If I do that, not found, not found. Why not found? Oh, because I know. Because we need in the index to add the route handler. It's going to be /id get order from the orders controller. Again, it's verified token. Now, if I send the same request to order/free, waiting, we have information about the order. That's the easy part. That's not too challenging. But the goal is to also add information about the items, right? Not only about them, but about the order. So let's go drizzle joins, because in SQL we use a join to connect to tables. So for example, we can select users, left join pets. Okay, left join. So we select orders. Dot left join item order items table, order items table, and we need to specify how do we want to create this join. We're gonna use the equal sign, and we're gonna equal from one table to another. So orders table dot ID should equal to order items table dot order ID. If now we're gonna send the same request, we see orders and order items, which is only one. But why is it? It's an object. I expect it to be an array. Left join bats. Why is it one? Oh, because it's a left join. It should probably be it's not exactly how I want. So probably a better way is the query method, because it's not exactly what I need. It's going to give me duplicate. It's an actual left join. So the problem is that the thing that we are joining on is not going to be the pets that is an array. It's going to be the result, which is an array. So it's going to be a lot of items there, from which we can probably do it. So it's going to be order with items, and you could do that if order with items length is equal to 0, then it's not found. Because if I do console log, you're gonna see what I mean here. If I just return it like this, maybe not with a left join. If I send the request now, you're gonna see an array with a lot of items where order is basically the same everywhere. Order ID 3, order ID 3, and that's it, because there are only 2 items there. And you could work with that by doing return const merged order is equal to an object where we destructure the order with items at position 0.order. Basically, we take the first one, or we can do a group by there. I don't know. So we take the first order, and then we say items is going to be order items dot map, and for a order item, we just take the order items, and now we return this merged. And if I look at the request now, it's an object with information about the orders and the items there. So I think that works as well. It works with a left join. It has a little bit of duplicated data. It's going to be performant because a left join on SQL works very, very nicely. But what I was doing before is I was using the query library. And I showed you the code. It's a bit less code because it's just this. You just query orders and you say with items true, but this requires to set up the relationship. So an extra step to set up the relationships, that would be, where is it? Declaring relations. Here, user relations. You have, for every table that has relations, you also have to export these relations, and only then it's going to work. So it takes a little bit of time just to set up these relations, like one to one, one to many. But then it's super simple to send this request with including multiple items without us having to do left joins and then doing this manual merging together of the objects. But I'm gonna keep it like this. Get order is there. Update order. Let's do the update order because it's not too complicated. So after get order here, I'm going to do update order. It's going to have ID from request parameters. It's going to have a body. It's going to update it in the table. Everything good. Only thing to do is in the order index to put it as router.put for the update @/ID. And here we need to verify the token and also to import update order. And probably even validate data, right? So validate data, update order schema, and let's go ahead and import update order schema from here. But we need to go back into the database order schema and define this update order schema. Export const update order schema, create insert schema based on the orders table. And we want to, maybe I'm gonna pick just to be able to change the status for now, because you can omit everything or you can pick, and I will only allow the user to update the status. So now we should be able to also update the schema. I'm gonna double check that. For example, order with ID 3. I'm going to do put with body status delivered. And if I do send, doesn't work. bad request status. Oh yeah, because this one's like this. Send. And here the status was updated to delivered. Okay, so that was updating. And the delete you can implement yourself. I don't think it's important to delete an order. Maybe it's not even needed. So I'll stop here because with this API endpoints, Denjik, with this API endpoints, I have everything that I need to view and manage products, create orders, and manage these products. So I'm gonna commit orders CRUD, and I'm gonna push these changes to our repository. And also I'm going to do npm run build. It doesn't want to do the build because what? Because in the insert, it doesn't like an insert, no overload in the orders index. Here, orders table, default, user ID, integer. Why it doesn't like it? ID PG column. ID orders. So it should be order.id. I'm going to somehow do a, I don't know, a TS ignore because it kind of works. npm run build. And I'm going to do cd in the root folder, and I'm going to do Genezio deploy so that I deploy all my new stuff to production. All right, guys, that was it. It took a little bit longer than I expected, but now we have a fully working API with a lot of things that you'd expect in a production-ready API. We have, I'm not even sure that I have the power to recap everything that we have done, but we started by creating the Express application, the Node.js application with Express. We set up the TypeScript. We learned about using Express with routes, with middleware, with controllers. We used Drizzle to create our database, to integrate with it, to save data, to filter, to fetch data. We added validation with some cool tricks of doing this automatically based on our Drizzle schemas to validate the requests. We added authentication, very important part, authentication and authorization. Everything is ready for us to use it. Maybe some endpoints need a little bit more adjustments because I have everything ready there with authorization of authentication. You just have to put them in the right place and maybe adjust like what actions do you allow to which role based. Maybe I'm going to do a couple of these adjustments later. You can check it in the GitHub because in the next live stream, we're going to build the user-facing application and later the dashboard. Today, we also learn how we can use Genezio to deploy our Express backend as a serverless function with really performant cold starts. And also we used Genezio for hosting our Postgres. This video was sponsored by Genezio, so thank you very much, Genezio, for making this possible. It was really easy to use and it made this project possible. All right, guys, if you enjoy this one, make sure to subscribe to the channel, turn on the notification bell, because as I said, we have still two projects to build in this series. We're gonna build the mobile application for our e-commerce, and also we're gonna build a dashboard in Next.js for managing the products and the orders. That was it. I'm Vadim from notjust.dev. Take care, stay hydrated, and I'll see you later.